We're hearing it's working now, Hearing Officer Chang.
All right, thank you. It's looking like it's working. I have the tech guy on phone. Let me close that call and then we can continue. And Blake Whittle is coming in to join us. Okay, thank you very much. Yeah. All right. Good thing you were standing by. I'll call you and talk to you about setting it up for tomorrow and other days. Make sure we don't run into this again. Okay. I'm sorry. Oh, University Avenue. Yeah. Yeah. Okay. Very good. Thank you very much. Bye. All right. Tech issue solved. Okay. We can go back on the record. And may I invite your opening statements? Who would like to proceed first? The Navy?
You're muted.
I shouldn't.
That's the time word of the year I've heard is you're muted. I apologize. Karen Minot is prepared to give the opening for the Navy.
All right, very good.
Good morning, Officer Chang.
All right, good morning.
I'm Karen Minot with the United States Department of the Navy. The United States Department, one moment please. We're gonna actually have the slides pulled up.
Yeah, 1 second, Karen. Mr. Chang,
So we're gonna have Razan go ahead and share her screen.
yes, Mr. Chang, I'm trying to share screen and I'm seeing that the host is disabled.
One more button to push. I'll be there.
All right, thank you.
Okay, you should be able to share screen now.
Yes, I see it. Thank you.
Great, thank you. All right. Razan, are you gonna do present mode?
Yes, I'm sorry. Give me 1 second, Karen.
Great, thank you. The United States Department of the Navy has applied for a permit to operate the Red Hill bulk fuel storage facility. The evidence and testimony presented at this week's hearing will show that the Navy's permit should be granted. First, because the Navy is fully compliant with every one of Hawaii's underground storage tank regulations, which were promulgated to protect the environment and human health. Second, because the Navy's operation of the Red Hill facility goes above and beyond those regulatory requirements to provide overlapping layers of environmental protection. The United States has invested hundreds of millions of dollars to upgrade procedures and infrastructure at the Red Hill facility, which has modernized the facility to protect the environment and make sure that the drinking water is safe. The Red Hill facility is more than just 20 Red Hill fuel storage tanks. The Navy also operates associated pipelines, a control room, tunnels, a pump house, an upper tank farm, Hickam product recovery tanks, Hickam airfield piping and hydrant pits, piers, and 4 surge tanks, each in accordance with the regular.
I lost the sound.
Exhibit N90 provides a cross-section view of one of the Red Hill tanks. The cylindrical vaults are 100 feet in diameter, 200 feet in height, and lined with 1/4 inch thick steel plates, with a minimum ground cover of 110 feet and built at least 100 feet underground. The steel line was built against a steel framework, then concrete was pumped over it, varying from 4 feet to 8 feet thick. Grout was then forced between the concrete and the basalt rock to ensure the steel was protected from deterioration, and the facility was hardened not only against attack, but from damaging elements of the environment. The Navy's permit application demonstrates that the Navy complies with Hawaii's underground storage tank regulations. The Navy's tanks and pipelines are properly designed, constructed, and installed, and meet or exceed the current regulatory standards. The tanks are protected from corrosion by 2 to 4 foot thick concrete walls that separate the steel from the ground. Twice a year, the tanks are tested for leaks using a method that has been certified accurate by third-party verifiers. The Navy's procedures for inspection and repairs at Red Hill go above and beyond the industry standard, using the best available technology designed for large underground tanks. Since 2014, the Navy has a different facility, both in its physical construct and how it's operated and monitored each and every day. The Red Hill facility utilizes advanced operational procedures and processes, such as when refilling tanks. There are visual inspections and personnel at the facility that have had increased training and certification. Additionally, fuel inventories are monitored every minute of every day with sophisticated automated fuel handling equipment system and automated tank gauging systems. The Navy employs tank gauging and trend analysis to monitor fuel inventories and has increased its tank tightness testing to twice what the regulations require. The Department of Health promulgated regulations applicable to underground storage tanks at the Red Hill facility pursuant to the Hawaii Revised Statute Chapter 342L. The Hawaii Administrative Rules found in Chapter 11, TAC 280.1 were developed to ensure underground storage tanks remain protective of the environment. The regulations include specifications for the design, construction, installation, maintenance, repair, and operation of the facility, as well as for release detection, reporting of releases, and response to suspected or confirmed releases. The Department of Health regulations conform to the United States Environmental Protection Agency's federal underground storage tank regulations. As the Board of Water Supply stated in its complaint initiating this hearing, the permitting process must carefully evaluate and assess whether the Red Hill facility complies with state law respecting underground storage tank operations. And that is the purpose of this hearing. The Navy's revised permit application and supporting documents presented in this proceeding demonstrates that the Navy operates and maintains the Red Hill facility in accordance with Hawaii's regulations. Testimony and evidence the Navy presented in support of this proceeding further demonstrates the continuing operation of Red Hill facility is protective of human health and the environment. The Red Hill facility has been inspected by the Department of Health and the United States Environmental Protection Agency. In 2017, a final evaluation report for the Red Hill facility, compiled by 5 petroleum, oil, and lubricant subject matter experts at the direction of the United States Environmental Protection Agency and the Department of Health. And it stated that it did not identify areas of non-compliance with current state or federal regulations. and concluded, quote, that systems and management practices in the place at the Red Hill facility meet or exceed best practices for petroleum terminals and bulk fuel storage facilities, end quote. The same report concluded that, quote, upon review of original design drawings and historical documents overall, key construction components of the tank exceed or meet most modern day construction standards, end quote. The inspection report also concluded that the tank's solid construction and location deep underground means that, quote, concerns of external factors are minimal, end quote. End quote. Damage mechanisms like distortion of the steel plates or other damage due to stress, seismic events, and settlement, which normally impact an above ground storage tank, are minimal or non-existent, end quote. Dr. Gore Johnson, the Navy's structural engineer, attached a report commissioned by the US EPA to evaluate the risk at EPA. The PME report agreed that the way the tanks are built deep underground and built into the bedrock makes them resilient to earthquakes. Furthermore, as the Navy's current Deputy Director of the Region Fuel Department testified, Mr. John Floyd, the recent October 2020 inspection of the Red Hill facility conducted by the same group of subject matter experts again resulted in no major findings reported to the Navy. Specifically, no contemporaneous fuel leaks or visible staining of fuel was found at any of the operational Red Hill storage tanks, surge tanks, above ground storage tanks, Hickam fuel storage, hydrants, or any of the pipelines. The inspectors reported to Mr. Floyd that the infrastructure was clean and pristine and that all automated fuel handling equipment, alarm records, and logs revealed that all alarm events were responded to correctly. The strategic importance of this facility to the United States Navy is relevant to this proceeding. The United States has invested now over $200 million and is programming over $400 million more to ensure the facility remains safe. To be clear, the continued improvements and investments in the Red Hill facility are not to increase the fuel capacity or provide additional fuel services to the military. The whole of the investment is to make sure the facility achieves the best available practicable technology, complies with the Hawaii underground storage tank regulations, and remains protective of the human health and the environment. The release of fuel in 2014 that led to the administrative order on consent, also known as the AOC, was certainly unfortunate, but it was not from corrosion or deterioration of the Red Hill tanks. There is no factual dispute that that release was due to human error, which was exacerbated by dated response plans that are no longer in place. The poor workmanship that led to the release would not be possible under the new and improved tank inspection, repair, and maintenance protocol, which includes an increased standard of care that was approved by the Department of Health and the United States Environmental Protection Agency in 2017. The AOC is an agreement the Navy reached with the Hawaii Department of Health and the United States Environmental Protection Agency to ensure the Navy is applying the best available practicable technology at the Red Hill facility to be protective of the human health and the environment. To do so, the Navy is in continuous cycle of researching and implementing state-of-the-art technology and processes. For instance, the Navy has partnered with industry and institutions such as the University of Hawaii to identify the best ideas and developments to enhance its processes, including how to inspect and repair the facility. Through 8 separate sections of the AOC's scope of work, the Navy has improved its inspection, repair, and maintenance processes, identified how to reduce risk, updated leak detection monitoring and response actions, enhanced its tank integrity program, and expanded its understanding of environmental conditions around the facility. The AOC provided as Exhibit N-001 was entered into to be, quote, fair, reasonable, protective of human health and the environment, and in the public interest, end quote. It is a binding agreement the Navy and Defense Logistics Agency entered into with the regulating agencies, the Department of Health and the U.S. Environmental Protection Agency. Moreover, the AOC is an iterative process where every process that has been reviewed and approved under the AOC is subject to being revisited every 5 years. Meaning at the first year review cycle, all of the lessons learned, as well as any updates and improvements to technology, will be implemented until the parties agree the AOC requirements are satisfied. For example, the non-destructive testing used by the Navy during its tank inspection, repair, and maintenance program employs what the AOC parties agree is the best available practical technology, and where the Navy learns lessons and develops new information from efforts such as destructive testing, it must necessarily improve its process per the terms of the AOC. Likewise, as the Navy develops new real-time tank integrity technology, such as permanent tank tightness testing techniques and continuous soil vapor monitoring, the Navy will upgrade the facility as well as its processes and procedures as the technologies become proven. This permit will not relieve the Navy from its existing obligations in the AOC to continue to upgrade and improve the facility through the AOC process. The AOC and the accompanying statement of work require the submission of certain documents, which are reviewed by the Department of Health and the U.S. Environmental Protection Agency, with technical input from stakeholders, including the Board of Water Supply. They are then approved conditions, modified, disapproved, and sent back for Navy to modify, or a combination of these. The submission of these documents do not depend on the issuance of a permit, and they will continue. The relevance of these deliverables to this proceeding is that the actions taken as part of the AOC process demonstrate the Navy's compliance or exceedance of regulatory requirements. Importantly, the AOC process is working, and the disputes clause, which provides for the off chance the parties cannot progress, has never been invoked. Since 2014, the Navy has improved many aspects of the Red Hill facility operation. Mr. John Floyd's testimony focuses on the operation of the Red Hill facility as it operates today, which includes layers of protection to prevent, detect, and mitigate. The Navy has improved and updated process related to fuel levels for its normal operations, changed the fuel refill process that requires intermittent tank tightness testing during the refill process with additional inspections and checks, enhanced the overfill protection, increase the number of full-time employees at the facility, increase frequency of inspections in a 24-hour period, revise and standardize operator training and enhance contractor qualification processes to improve tank inspection and repairs, implemented new procedures for rapidly draining tanks that allow operators to transfer fuel out of a tank within 36 hours, improved procedures and implementation to more accurately inventory monitoring and trend analysis, using automated fuel handling equipment to identify a fuel release, however unlikely, more accurately than in the past. Additionally, operators are now required to report alarms immediately, and operation supervisors reviews the alarm logs to confirm there are no unscheduled fuel movements. These protocols are designed to correct prior breakdowns and identify a potential release more accurately, reducing the potential volume of released products and thus providing better protection of drinking water. Mr. John Floyd's testimony also provides how the Red Hill facility conducts inventory monitoring using the automated fuel handling equipment system known as the AFHE and the automatic tank gauging system known as the ATG. Each tank has an ATG probe that measures the level of fuel in each tank. The ATG data is transmitted to a central computer that is used to monitor and control operation of the system and is monitored 24 hours a day, 7 days a week from the AFHE control room, as seen here in Exhibit N-091. Furthermore, the 2017 final evaluation report for Red Hill concluded that the Red Hill facility control system contains all the expected components and features and is by far exceeding industry standards by upgrading a system that is only 10 to 12 years old. The Department of Health and United States Environmental Protection Agency approved the Navy's tank inspection, repair, and maintenance procedures, known also as the term, which are now being implemented for in-service tanks at the facility. The Navy is firmly committed to protecting the environment and drinking water supply through continual improvement of the Tank Clean Inspect Repair program. Since the fuel release in 2014, the Clean Inspect Repair program has been overhauled to add new tank repair specifications, include a 3-step repair process, additional checks and balances, additional staffing for better quality control, including a third-party quality assurance engineer that provides objective feedback on Navy contractors' performance, completion of repairs, and implementation of Navy standards, as well as enhanced tank refilling procedures. These processes and procedures are new and were not previously in place at the time of the 2014 release. The Navy tank inspection, repair, and maintenance practices implemented at the Red Hill facility are governed by a standard of care and safety that exceeds American Petroleum Institute Standard 653 that has been modified in order to accommodate the parameters of the Red Hill underground storage tank system and exceeds usual industry practice. In an effort to continue to improve, the Navy has invested approximately $1.9 million with the University of Hawaii's Applied Research Lab and College of Engineering for continued enhancement to the term process. The Quantitative Risk Vulnerability Assessment, known as the QRVA, is a risk assessment set at a particular point in time that identified areas where the Navy can reduce the risk of a potential release from the facility. It is not a prediction of the future. Phase 1 of the QRVA is the first phase of a multi-phase process that identifies sources of potential risk related to the Red Hill facility, which the Navy is in the process of or has already addressed to reduce the risk of a potential release. However, as Commander Frame explained in his testimony, the model of the QRVA freezes the facility design as of July 27, 2017, resulting in the numerical predictions being based upon the conditions in the facility at that point in time. Any improvements made since that time, such as eliminating the smaller nozzles in service and revamping the tank filling process, are excluded from this QRVA analysis. This alteration of nozzles began with the tank inspection, repair, and maintenance performed for Tank 5 and is currently being implemented in Tanks 13, 14, and 17. Commander Frame's testimony further explains that in addition to removing nozzles to reduce risk, the Navy is also installing new pipe stands, which are intended to reduce stress on nozzle flanges and are also replacing the product line ball valves. With regard to how the facility operated, the Navy has also reduced fill in the tanks from 212 feet down to 190 feet or less. These measures were not in place in 2017 when the facility was assessed and have reduced the overall risk identified in the QRVA. The Navy also meets or exceeds the regulatory requirement regarding tank tightness testing. The Navy conducts twice as frequent tank tightness testing at the Red Hill facility than required by Hawaii state requirements. Since 2019, each Red Hill tank containing petroleum product has undergone biennial tank tightness testing as a best management practice. The Navy is also pursuing a project to install permanent tank tightness testing equipment in every tank. Mr. Chris Caputi's testimony provides the tank tightness testing method is approved by independent third-party evaluations and is listed on the National Work Group for Leak Detection Evaluations, an organization known as NWG-LDE, which is comprised of 9 regulators and an industry expert. The selection of leak detection methods utilized for the Red Hill facility follows accepted industry standard approach that focuses on identifying the leak detection criteria required for the site and selecting a method that is capable of meeting those criteria. In this industry standard approach to use independent third-party evaluations and NWG LDE listed technologies for the determination of the performance standards of a leak detection method. Mr. Chris Caputi's testimony also provides that leak detection for underground piping for Red Hill was tested utilizing leak detection methods that are also third-party evaluated and listed with the NWG LDE to meet the required rate for each testing section. These leak detection methods are standard approaches to leak detection testing of bulk piping systems throughout the DoD and commercial industry, and were selected based on having appropriate third-party evaluations and listing on the NWG LDE website. Lastly, Mr. Chris Caputi testifies that underground piping was static liquid pressure tested in conformance with industry standard practices accepted to the U.S. Coast Guard. The testing is required to ensure that no leaks occur under a static liquid pressure of at least 1.5 times the maximum allowable working pressure. This method of pipe leak detection or integrity evaluation is the longest serving and most basic approach of testing employed in the industry. With respect to the testing of pipeline systems associated with the Red Hill facility, the final inspection report for the Red Hill facility, which is provided, states that the subject matter experts reviewed the API 570 inspection reports of the piping system and concluded, quote, the piping system inspection process meets or exceeds industry standards, end quote. The Navy meets all regulatory requirements for corrosion protection in accordance with Hawaii state regulations and uses the best available technology to identify and repair any anomalies in the tank liner through its term processes. The Navy incorporates the best available technology in accordance with American Petroleum Institute standards, which are modified to increase the standard of care at the Red Hill facility. In fact, as provided in Navy testimonies, the Navy goes above and beyond the American Petroleum Institute standards by manually inspecting the entire interior surface with non-destructive technology, the accepted industry technology, as part of a modified API 653 procedure during each clean, inspect, repair project. As part of the AOC process, the Navy continues to identify and implement improvements to the non-destructive evaluation process that would be incorporated in the next review cycle in the AOC process. The vast majority of releases of fuel from the Red Hill facility occurred before 1988, and none have occurred since 2014. We believe the evidence will show that more than 80% of the releases occurred prior to the inception of the 1988 underground storage tank regulations. Moreover, many reported releases did not result in releases to fuel to the environment. Approximately 30 reported releases were through a poorly designed telltale system were likely captured in a tank drainage system. Likewise, there are reported releases of water which was placed in the tanks during inspection and repair periods. They cannot be confused for releases of fuel from the facility, and others concern defects on the upper domes well above the fuel line. As presented in Commander Darrell Frame's testimony, several reported releases are historic or based on non-contemporaneous reports that identify the release. And of the known release of the fuel from the tanks at Red Hill, the drinking water has remained safe. To detect any slow or chronic releases of fuel, the Navy conducts monthly soil vapor monitoring for volatile organic compounds, or VOCs, in the soil beneath each of the 18 active Red Hill tanks. 3 soil vapor monitoring probes are located beneath each of these tanks. Moreover, to improve the release detection processes for this facility, the Navy is pursuing additional technologies to expand the soil vapor monitoring system to provide continuous soil vapor monitoring. To ensure detection of any fuel releases that move through the 100 feet of rock between the tanks and the aquifer, the Navy also has a groundwater monitoring network that surrounds the facility. As shown in this map from page 55 of the facility environmental report, there are currently 19 monitoring wells in this network, with 8 more scheduled to be added by the end of 2023. As Kurt Stanley points out in the facility environmental report, samples from each groundwater monitoring well are collected and analyzed on a quarterly basis. These samples show that detections of TPH in groundwater are limited to the area near the tanks and are not affecting the perimeter wells. Neither the Navy's Red Hill drinking water shaft nor the Board of Water Supply's Halawa shaft have ever been impacted by any past releases. Furthermore, as the Board of Water Supply presents in its complaint to initiate this hearing, quote, testing conducted to date indicates the water provided by Board of Water Supply drinking water wells remains compliant with standards for safe drinking water, end quote. In fact, the Board of Water Supply's own data shows that neither petroleum nor any of its constituents have been detected in sampling results. Thank you.
Thank you very much. Does Board of Water Supply want to present its opening?
Absolutely. Thank you, Hearing Officer Chang, and good morning. For the record, my name is Ella Foley-Gannon, and I'm with the law firm of Morgan, Lewis, and Bacchius, and I have the honor and privilege of representing the Honolulu Board of Water Supply in this proceeding, this critical proceeding. And I think as we start out, it's really important to underscore how critical the issues are that are going to be decided by the Department of Health in this matter. It just absolutely cannot be overstated how important this is. What this is going to determine is whether the water supply that supplies the people of Oahu and supports the environment of Oahu is going to be safe today, tomorrow, and for generations to come. If the decision is made to allow the Navy to continue to operate the facility in the manner that it does so and is described in the permit application, we believe that simply cannot be guaranteed. And as a sort of framing device to think about, I think you think about kind of what is risk tolerance and what is, kind of you do a cost benefit analysis. And so when you think about a thing that has such a catastrophic possible cost, the cost of losing this precious, unreplaceable water resource for the island of Oahu. That therefore requires that the risk that can be allowed and tolerated has to be really, really small, because it's just too big of a risk. And when you look at the evidence that's presented in this matter, I think the only conclusion you're going to be able to come to is the Navy can't meet the burden. It can't meet the burden of showing that it's complying with the statutes that govern underground storage tanks in Hawaii. It can't demonstrate that it's satisfying all of the regulations of the Department of Health. And it certainly can't demonstrate that can be operated consistent with the overall public trust obligations that are established in the Constitution that guarantees protection of the water resources. So again, we think when you're taking an eye to this evidence, we really ask that that be kept in mind. The consequences are so great, the risk cannot be great. The risk has to be really, really small. And again, they're not going to meet that. The Navy, in its evidence, presents a lot of documentation and a lot of discussion about these systems and systems within systems that are there to protect everything, and that there are layers of protection. But we're going to ask you to not take them at their word, but to really look at and examine the evidence that's before you, that shows really what is going on at this facility and what the risks are. And when we talk about layers of protection, there's really only one layer of protection at this facility. And that layer of protection consists of a 1/4-inch piece of steel. I think a 1/4 inch is like this coffee stirrer. I mean, that's about 1/4 of an inch. So that's really the only barrier only meaningful barrier between the fuel and this precious resource and the environment. And this layer is also subject to corrosion. And we know that. They'll talk about all of this corrosion protection that is out there. But we know that there, and you'll see pictures of this. You can look at this in the record. The only views that we've actually had of the outside of the tank, the side of the tank that they can't see, the side of the tank that they can't repair, the side of the tank that they can't maintain, is that it has corrosion. When we talked about the destructive testing that was done, and we'll talk a lot about it this week, they removed 10 coupons, which are just like a section of the tank, right? They cut it out, they take it out, they looked at it. And again, we'll go through this and talk about what the meaning of it is. But when you look at that, you look at those pictures, there's corrosion that's existing on each one of those coupons. Some have more than others, but there's evidence that shows that it's corrosion that is continuing to happen. And how do we know that? We know that because when they do the trim, when they do the inspection and repair, they keep finding places where the through walls, where the steel is being reduced in size. How would it be being reduced in size if there wasn't corrosion happening? What would they be testing for? What would they be seeing? They wouldn't be seeing anything. They have to even to undergoing these inspections, they're having to acknowledge that there is a rate of corrosion that's happening. And they say that this can't really be happening because it's all protected by this concrete. But we see that water is getting in there. And we see that. I mean, you saw when you were walking through the facility, we saw water dripping down. I mean, there's water that is coming in contact with the steel. And again, when those coupons were taken out, many of them were wet on the backside. So there is water. When you have water in this environment, you have the oxygen that is necessary to allow for corrosion to happen. So again, we know that this is happening. And the evidence, we represent that when you take a careful look at this evidence, Hearings Officer Chang, you're gonna see, again, we've got a quarter piece of steel, it's corroding. And that's what's there to protect it. Now, again, they say that the concrete also protects it. And the concrete is also holding the fuel in. But we know that this is not true either. And how do we know this is not true? Because when there's been spills, the fuel has gotten out of the tank and it's gotten into the environment. We know that because they do soil vapor testing that shows that there are fuel constituents in the soil, in the environment. When core samples were taken from rock, there was fuel in core samples from the rock. We know that it's gotten into the groundwater. The Navy's own witness, Curtis Stanley, says the Navy never pretended that the fuel has not ever reached the groundwater. So we know it's not being held in the concrete. It just simply can't be because it's gotten into the environment. And we know when the release happened in 2014, it got to the lower access tunnel, and there was actually a big oily spot right under tank 5. And at least when I was there, it seemed to be that you could still see evidence of that. And we certainly have seen pictures, there are pictures in the record that will show that. So again, there is concrete there, but it cannot possibly do the job that the Navy says it does, which is that it keeps the fuel in it. So again, layer upon layer of protection, it's really one layer. It's one layer that's a 1/4 inch of steel, that's old, that's corroding. So if this is the case, well then it's really, really critical that they can make sure that they can test these things, they can repair them, they can maintain them. So they have this trim process. And again, you're going to hear a lot about this, but there are some very, very significant problems with this. First off, just from a practical standpoint, the pictures that they just showed, and when we were there in tank 13, we saw it, you know, the way that this is done is they're hanging from that basket. There's people hanging from the basket that are along the walls of the tank. They're using a handheld device to scan every inch. And they have to look at that and they have to note when there's an irregularity. And that's how they identify problem areas. And then they make those circles. We saw all those circles on the walls. And you'll see lots of pictures of them. We saw them when we were there. So you can see that there's a lot of areas that are being identified. But this really demands perfection from people hanging hundreds of feet above the air with a little handheld device and doing it for days upon days upon days, because this liner is the size of a football field. I mean, it's a huge task to ask people to do. And so it seems incredible to imagine that there aren't going to be things that are going to be missed. And so to have to say that that's all we have to rely upon to make sure that we're not going to have any of the corrosion eating through, that we're not going to have this fail eventually, this old steel that's being worn away, that's being corroded. This is, again, this is a huge risk. Consequence, terrible. The risk is way too high. This is just not a reliable system. And then there's also the additional problem that when they tried to prove up, and there was a lot of talk in the opening here and throughout the evidence about how that it's okay because the AOC has confirmed that all these things have been done. But the reality is a large majority of the things that have been submitted as part of the AOC have not been approved. They've either been disapproved or they've been said that they don't actually meet the requirements and you got to provide more information. So really this again does not lower the risk. This does not get us to a place where we can be comfortable with it. And so when we look at the validity of their trim process, they conducted an assessment of tank 14, and they had done an analysis with their non-destructive testing. And then they took out the coupons, and this was supposed to verify, did you catch the spots that were really wearing down, that needed to be repaired? And what was the results of that? 50% of the time they were wrong. Now, there is no way we can say that that's an acceptable risk. I don't think anybody can say that that's an acceptable risk. If you're going to miss it 50% of the time, and they're going to tell us that that's okay, they've learned lessons and they're going to make it all better. But until we can see that, until we can know for sure that they can do what they say that they can do, that they can make sure that there's no way that these things are going to be there, that there's going to be leaks, that there's going to be through holes. Again, our position is that's just too high of a risk. We can't live with that. We absolutely cannot live with that. Another problem with their trim is that under the industry standard and under the guidance from the EPA and from the Department of Health, and even under their own policies, they're supposed to be testing these tanks every 20 years. And we can talk about, and our expert, Dr. Norfleet will testify that there's really some problems with the way that they calculate the acceptable period of time. But even if we really don't quibble with that, even if we say, okay, 20 years, that's sufficient to say you're going to get back in there and you're going to test it, and assuming you can actually do this all perfectly, you're going to catch anything before it really becomes a problem. But when you look at the evidence, they don't meet that 20 years most of the time. As noted in a letter from the EPA and from the Department of Health, it's really been on average of about 30 years. So it's a third more than it's supposed to be, even under their own calculations and under the industry standards. And again, we're talking about a facility that presents a huge risk, and they have not been doing it. I'm sure they're going to tell us it's okay, we will in the future, but that's not the evidence before you. That's not what you can base your decision on. So you have to look at what they've done. And the longest tank that went without inspection, 58 years. This is only an 80-year-old facility. 58 years without them doing any testing or exploring. And that's supposed to give us the level of assurance we need that says that there's no way that this quarter-inch steel is going to erode and is going to fail, and we're going to have a risk, and we're going to have it. So that's really their only way of preventing. There are other measures that they talk about are really focused on detection, not prevention. So it's supposed to detect leaks that happen. Well, that doesn't give us an awful lot of assurance because it happens after a leak has already occurred. Again, we want to see measures that are actually going to prevent the leaks from happening. They can't do that. And there are even questions about whether the adequacy of their leak detection. And we'll talk about that. And part of the problem is that there's also such a lack of transparency that we don't have a lot of the underlying data. So we don't know for sure how their leak detections work. We know that the method that they use has been approved, but we haven't seen the details. And again, this is such a huge risk. We can't accept that. That in our position, that cannot be deemed to be sufficient evidence to show that they're complying with state law. So without that evidence, we just can't go there. And finally, their final area is all focused on being able to be protective of health in the human environment and ultimately the mitigation that is going to be done. And so what does the Navy do about mitigation? What does it do about mitigation? It says, we don't have to do anything because it's really fortunate. We have these soils that can just act like a sponge and can just hold huge amounts of fuel that may be spilled. We don't believe that the evidence shows that. We don't believe that there is any documentation that shows that. They also say there's natural attenuation happens, and it's going to happen fast enough that it's going to make sure that all this fuel that's being held in this spongy rock is never going to get anywhere. And again, we agree natural attenuation happens, but we don't believe that the evidence demonstrates that it happens at the rate that it can, and that you can really adequately rely upon both of those things to ensure that in the event of these future releases, and particularly if there is a catastrophic release, which really can happen when we talk about the fact that we've got hundreds of millions of gallons of fuel in old tanks, which have corrosion that's only 100 feet above the groundwater resource. This unreplaceable groundwater resource. That again is just too big of a risk. And they tell us that it's okay because they've been monitoring it and it hasn't gotten to our drinking water yet. Well, that's not the standard. The standard isn't that we have to wait until our drinking water is contaminated and we've lost this irreplaceable resource. The responsibility of the Department of Health and the Board of Water Supply is to make sure we protect that water resource today. And that's what we're trying to decide here in this case. That's what we have to make sure that we can accomplish. They also say that they can make this determination that it's never reached anywhere because of this extensive monitoring well program that they implement. Well, let's look at that a little bit closely too. It's extensive because they have 3 2-inch wells in a 13-acre field, which is in a groundwater system, which is so complicated and complex that they've been trying to model it for years and they don't seem to have gotten it right. Again, because of the lack of transparency, we don't know for sure because they haven't produced that groundwater model so that we can actually understand what they know about how things move in this system and what they can actually say and prove about how these factors should all be interpreted and played into it. And finally, they say, well, if there really was a major catastrophic release and it got to the groundwater and started contaminating things, you don't have to worry about it because we could always pump it through Red Hill and we could always treat it. Well, there's a lot of problems with that. First off, they don't have a treatment plan. So if this happened today or tomorrow or 3 years from now, they couldn't treat it. It simply doesn't exist. We understand that they're undergoing a feasibility study to look at it, and that's all great. But today, the facility that they're asking you to permit simply cannot do that. They also haven't really considered what happens to the drinking water resources if you have to take all of that out of the system, and how long would it take? Nobody knows. So once again, we talk about this huge catastrophic problem and this risk, which is really, really high, based on the information that we have and based on the information that we don't have. This is simply an unacceptable situation, and it cannot be allowed to continue. It cannot be allowed to continue to operate because it does not satisfy the requirements of Hawaii state law. And again, we'll walk through that with you in particular with all of the Navy's witnesses, with our own witnesses. But those are the major things that we wanted you to be aware of as we start to enter this. Again, the Navy says a lot of things about all of this stuff, and they ask us to trust them. Well, that's really hard for us to do, again, because A, they haven't been transparent. B, they have not done everything that they said that they're going to do. And they also want us to rely on the fact that they're going to do more improvements. Well, that's great, but you can't rely upon that today. Today, you have to rule on the application that's before you. And the third problem is a lot of what they've done in the studies, as I mentioned earlier, as part of the AOC, have actually been have been found to be inadequate by the Department of Health itself and by the EPA. So all of the real layers that we have to look at all point in one direction. You cannot issue this permit and be consistent with Hawaii state law. It cannot happen. And what the board asks for you to do is instead tell the Navy that they have to move those tanks away from the groundwater resources, or they have to install secondary containment so that there really is a barrier between the fuel and the environment, which can be put at such great risk. So again, we ask that you deny the permit for these reasons, and we look forward to the opportunity to discussing this evidence further throughout this proceeding. Thank you.
Great, thank you. I think we're at a point, perhaps we should take a short break, give people a few minutes to rest and re-energize. Is that all right? Is 10 minutes sufficient?
That works.
Yes.
All right, let's take a 10-minute break. We'll see you then.
Thank you.
Do we have everyone back who needs to be back?
The board does.
The Navy does as well.
All right. I think we are ready to resume. Let's go back on the record and Mr. Frankel, are you ready to give your opening statement?
Sure. It sounds like somebody might have a leaf blower in the background. I don't know if they need to be muted. No, Donna, that might be you.
Yeah, I'll mute myself.
Okay. All right, Mr. Frankel.
Okay. The Navy has polluted our water and will do so again. That is simply unacceptable. From the very beginning, the Navy's Red Hill tanks have leaked. In 1949, tank number 16 was leaking 546 gallons of fuel per day. And on some days, the tank leaked more than 1,550 gallons of fuel. Tank 3 leaked 60 gallons per day, and tank 17 leaked 20 gallons per day. In 1958, a tank leaked 1,500 gallons of fuel. In 1971, a Red Hill tank leaked more than 20,000 gallons of fuel. In 1980, another tank leaked more than 25,000 gallons of fuel. In 1998, the Navy casually noted that, quote, there are leaks during normal operation. In 2002, the Navy confirmed the release of fuel of unknown quantities. In 2014, a Red Hill tank leaked 27,000 gallons of fuel. Why have these tanks leaked? Sometimes it was due to poor design, sometimes due to sloppy construction, sometimes due to inadequate oversight, sometimes due to bad repair work, sometimes due to corrosion, and once during an earthquake. If anything could go wrong at Red Hill, it has. It is undisputed that these leaks have contaminated our water. Navy report after report reveals that these tanks have contaminated our water. The Navy's 2007 technical report concluded, quote, the results of this investigation clearly indicate that petroleum has been released from the facility in the past. 3 groundwater monitoring wells were installed within the lower access tunnel of the facility, and samples from each have consistently detected petroleum dissolved in the groundwater beneath the site. The current level of impact to the environment exceeds the Tier 1 action level standard developed by the Hawaii Department of Health for groundwater that will be used as drinking water. The Navy's 2008 Groundwater Protection Plan, its 2010 audit, and the Navy's 2020 Investigation and Remediation of Releases report all conclude that the tanks contaminated our groundwater. These tanks will leak again. The Navy calculated the likelihood of fuel leaking outside the Red Hill facility. And that means, I want to be clear here, not just confined to that long tunnel we walked through at the bottom of the elevator. This is outside the facility. This is their calculation. Its quantitative risk and vulnerability assessment concluded that the probability of a sudden leak of between 1,000 and 30,000 gallons over the next year is 27.6%. that risk jumps to 96% over the next 10 years. So we know these tanks will leak a lot of fuel. And by the way, one of the fundamental assumptions in this report of risk is that these tanks are inspected once every 20 years. That's a basis of the calculation. But these tanks have not been and will not be inspected once every 20 years. In addition to these acute incidences, the facility is also expected to chronically and continuously release 5,803 gallons of fuel per year. Think about that. In addition to any acute releases, these tanks are expected to release more than 5,800 gallons of fuel every single year. The Navy has identified a number of steps it can reduce the risk of more releases. Decommissioning the small nozzles, coating the interiors, inspecting the tanks frequently. The TIRM report actually calls for the Navy to do these inspections once every 10 years, unless circumstances allow for a longer period of time, up to 20 years. Think of our site visit. When we looked at tank 13, that was the first tank we looked in. The Board of Water Supplies Council refers to the circles on the walls. I call them more amoeba shaped. In any case, whether they're circles or amoebas, those shapes indicated areas that needed to be repaired. The report for that tank inspection revealed there was quite a bit of corrosion on the back side of this tank. The inspection report required mandatory fixes for these corrosion spots. They were so important because of the threat they posed. And how long it had been before this tank had previously been inspected? What was the interval between inspections? 25 years. In that 25-year period, the Navy concluded that the tank had degraded so much, mandatory repairs needed to be made. Despite a list of items the Navy recognizes need to be taken to reduce the risk, the Navy has not come close to implementing these measures. The Department of Health concluded that the storage of up to 187 million gallons of fuel 100 feet above a drinking water resource, quote, is inherently dangerous. A 1998 Navy study concluded that an uncontrolled massive fuel release from the Red Hill fuel storage and distribution facility would cause irreparable damage to the drinking water source below the site. Also, the cost of cleanup would be prohibitive, long-term, and may not be completely successful. In a 2010 audit, the Navy concluded that, quote, the environment in the Pearl Harbor area has not been sufficiently protected from the Red Hill fuel tanks. Given the Navy's track record, the inevitability of more leaks continuing to occur, and the importance of our groundwater, the Red Hill tanks cannot be and are not operated in a manner that is protective of our water. There is a practical alternative. Build new tanks above ground in a safe location. Relocate the fuel, just as the Navy did on the mainland. The Navy's history of leaks is shameful. The likelihood of more fuel leaks is unacceptable. Contaminating our groundwater, whether that water is used for drinking water today or not, is simply unacceptable. The Navy cannot be given a free pass to ruin our water. The Department of Health must conclude that the Navy's permit to operate its antiquated and leaky tanks is unacceptable. Thank you.
All right, thank you. For IHA, any opening statement?
Waive.
All right, thank you. Are we ready to begin with testimony?
Yes, sir. The Navy's ready to present its first witness. He did dial in earlier. There may have been some confusion on the timing. So we're going to dial him up right now if we could just be patient.
All right, we'll await that process. The Navy's going to be calling Officer Whittle.
Yeah, Commander Blake Whittle, yes, sir. And he's the one who dialed in earlier. And
Okay.
we asked him to stand by. Mr. Chang, can you see if he's pending in your queue to be let in? He said he's just waiting to be admitted.
Yes, he is, and he is joining us.
You ready?
All right, welcome, Commander Whittle. May I ask you to take your oath? Ms. Baba, would you administer the oath, please?
Please raise your right hand. Do you solemnly swear or affirm that the testimony you're about to give will be the truth, the whole truth, and nothing but the truth?
I do.
Thank you.
All right, who will be, is there any introduction on the direct testimony?
Yes, sir. We intend to just do a brief introduction with our witnesses to provide some context and then pass them across. Karen is going to be handling Commander Whittle. Thank you.
All right, thank you. Ms. Manat?
Yes, good morning. Here we have Commander Blake Whittle. He was the Regional Fuels Officer at Naval Supply Systems Command, Fleet Logistics Center, Pearl Harbor from 2017 until June of 2020. And in this position, he was really responsible for all bulk petroleum operations across the Joint Base Pearl Harbor Hickam, and including the Red Hill bulk fuel storage facility. Commander Whittle, are there any corrections you would like to make in your direct testimony?
None at this time.
Thank you. Be happy to turn over Commander Whittle for cross-examination at this time.
All right. Do we have an agreed sequence that the Board of Water Supply will commence the, all right. Then for the Board of Water Supply, your cross-examination, please.
Thank you, Hearing Officer Chang. And good morning, Commander Whittle, and thank you for joining us. I am counsel for the Board of Water Supply. Just have some questions about your testimony. There is references in your testimony to the fact that there are 2 tanks that have been taken permanently out of service. Can you explain why those tanks were taken out of service?
Yes, before I do you have a preferred form of address, ma'am?
Oh, you can call me Miss Gannon.
Thank you, Ms. Cannon. To get into the complexity of why those tanks are taken offline, you have to understand that fuel is managed worldwide by Defense Logistics Agency for allocation of the resource globally. So effectively, when you break it down into each theater, you have a geographic combatant commander. Under each geographic combatant commander, in this case, Indo-PACOM, you have all the services. So Pacific Fleet, USERPAC, the Army component, PAC-F, the Air Force component. At each one of those locations, there's fuels planners, and they effectively plan what would it take for the most strenuous possible operation that we have currently on the books, or operational plan, we call it, OPLAN for short. What are the requirements for fuel for that? Once they've done that analysis for their component, they send that up to the Joint Petroleum Office at the Indo-PACOM level. From there, Indo-PACOM makes a determination on the requirements for fuel at a classified level that are needed theater-wide. They push that information to Defense Logistics Agency, and Defense Logistics Agency pushes an unclassified inventory management plan, or IMP for short, out to all the DFSPs, Defense Fuel Support Points, across the DoD. That determination tells the facility how much it's required to store. In the mid 80s and again in the 90s, we saw a drawdown in forces and a reduction in requirements for fuel burn as we gained efficiencies in how we burn fuel. In both those cases, the determination was made to take tanks offline Red Hill because they were no longer needed to meet that storage requirement for the DoD. That's why those 2 tanks were taken offline.
And so there was how were these 2 specific tanks chosen, or was it chosen at random?
I don't believe it was chosen at random. To the best of my knowledge, one was taken offline in 88, I believe, another one in 99. And they're both turned offline because of their coming up in their repair cycle. So the determination was made, instead of repairing those tanks, we'd have actually put them into what we might in the Navy call layup. Effectively, they'll no longer be used to store fuel.
And have those tanks been formally closed?
No, those tanks have not been formally closed. They are no longer in operating status and not connected to the network.
And generally, when you would formally close the tank, what would you do with it?
I can't speak to it because a Red Hill tank has never been closed, so I don't know how I'd make a determination on what would happen to a Red Hill tank when it was formally closed.
Are you aware of the requirement in Hawaii state law that when tanks are formally closed, they are either removed or filled with an inert substance?
I believe that has been common practice for other underground storage tanks, yes.
But that has not been done here.
Those 2 tanks have not been filled with dirt or soil.
Thank you. Turning now to on page 6 of your testimony, you describe the monitoring system which is in place at Red Hill. What's the purpose of the monitoring system?
I'm sorry, I apologize. What monitoring system are you referring to? There's several.
Will you talk about the 2 that you describe are the automated fuel handling equipment and the tank tightness test? What is the purpose for both of those?
The automated fuel handling equipment is both to monitor the inventory within the facility, the fuel itself, as well as to allow the movement of fuel for that facility. So that's how you control fuel movements. That's the primary purposes of the automated fuel handling equipment. The tank tightness test is an independent process, not part of the AFHE, which validates the tanks are tight, that they are not leaking.
So these are leak detection methods and not leak prevention methods, is that correct?
Yes.
Thank you. Just going back to the automated fuel handling system, so you describe this as a continuous monitoring of fuel levels. What level of fuel change has to occur for it to be detected?
It can detect down to 1/16 of an inch.
And how much would 1/16 of an inch equate in fuel in a tank of this size and scale?
Roughly 320, 330 gallons approximately.
And when does an alarm go off?
At the half-inch level.
And the half-inch level would be how much fuel approximately?
I need a calculator to do the public math. I apologize. And
Okay.
2,000-ish gallons, what's 8 times 300? So 2,400 maybe.
Yeah, 2,400 gallons would be about approximately it. Okay. And what do you do when an alarm goes off?
Well, for starters, unscheduled fuel movement, that was an actual alarm of fuel removal, never happened in my time operating the facility. So again, I'd have to speak not from what you do, but from what the standard operating procedures and practices tell us we would do. Because you get many alarms throughout the facility, but they aren't the alarms you're referring to. Because different things can occur in the facility, it's a little bit complex. So you're saying if an operator, actually, I apologize. Could you clarify the question?
Sure. So you've said that if there was a 2,400 gallons of fuel all of a sudden leaked, or there was a decrease in 2,400 gallons of fuel, an alarm would go off. What would you
Correct.
do at that moment?
You check to make sure that you hadn't improperly programmed a procedure. That is the most common thing that's going to happen. If you don't evolve every part of the system when you do a scheduled fuel movement, you will get an unscheduled fuel movement alarm. So that would be the initial reaction. The second is to check for bleed by or other things occurring in that valve. Have you seen pressure changes on the skin valve or otherwise inside outside of that tank to determine why that fuel level has changed on you? I'd pull up most recent trend analysis and see if there's any inconsistencies there. And then we'd likely begin drain down procedures if we had a validated unscheduled fuel movement.
So if you suddenly release 2,400 gallons of fuel or more, you go through these processes. Once you decide it's really a leak, then you start drawing down the fuel. Is that correct? Is that what you said?
Yes. Yes.
And how long would it take you to empty the tank?
It's dependent on the height of the fuel in the tank.
On average.
You can't get an average. That's impossible.
Okay, a full tank.
Full tank, anywhere from 12 to 24 hours.
And during that 12 to 24 hours, would you be able to do anything about the leak?
No, you would not. But if you draw down to below where the leak is occurring, the leak would stop.
Right. But your leak detection wouldn't tell you where the leak was occurring, would it?
No, it would not.
So you could have the leak continuing to occur for 24 hours before the tank was empty. Is what I take from that. Is that correct?
Yes.
So you said that you haven't had the alarm go off while you've been there. Did the alarm go off when tank 5 leaked in January 2014? And what did they do?
They improperly reacted to that alarm.
What was their reaction?
They silenced the alarm.
They silenced the alarm. They didn't do anything.
Correct.
Thank you. Then you describe the tank tightness test, and you indicate that you're now doing those twice as often as required. Has that been done on each tank?
All the tanks are in service. Yes, you can only conduct a tank tightness test on a tank that's full of fuel.
So how many of the tanks have been subject to this twice a year tank tightness test at this point?
All the tanks are in service with fuel in them.
And how many is that, please?
14.
So the 14 tanks have had them done twice a year. And how long has that been going on?
In 2008, before regulatory requirements, we began initiating tank tightnesses on a biennial basis. At some point after 2008, we moved to an annual requirement, again, before there was any regulatory requirement. I believe in the 2010s, it became a regulatory requirement to conduct it annually. At that point, we moved to semi-annual tests.
Okay, thank you. You also noted that no tank has ever failed a tank tightness test since you've been doing them. Does that include, was there a tank tightness test done on tank 5 before the?
There was, yes. A few months before it was taken out of service, there was a tank tightness test completed on it.
And did it pass the tank tightness test?
It did.
So a tank tightness test, as I understand it, is really talking about whether a leak is happening right at that moment. It doesn't predict whether there's going to be future leaks.
Yes, that's correct.
So it's only talking about kind of things that have already occurred. So because a tank has passed a tank tightness test doesn't mean that there won't be a leak. Is that correct?
Correct. In the case of tank 5, it passed a tank tightness service. Tank tightness test was taken out of service, and a contractor properly performed maintenance and drilled holes through the integrity of the tank, which weren't properly repaired. They did not predict contractors' improper maintenance procedures.
Or any other thing that could happen in the future. So again, it's just speaking to a moment is my point, is that it's just telling you at that moment, it's not detecting a leak.
Yes, it cannot predict the
Up to the
future.
level that it can measure it, right?
It cannot detect the future, yes.
And what's the smallest leak that you can detect?
EPA requirements require half gallon per hour certification. However, we clearly showed in section 4 of the AOC, the current system we're using well exceeds that threshold.
And when you say exceeds, what rate can you get?
I believe in the short pattern test, we were able to almost double the requirement. However, my understanding is when we're able to install continuous leak detection monitoring, that will rapidly approach much lower numbers.
But that's not in place right now, correct?
No, that is not in place right now.
Okay. So right now, could you detect, a 0.1 leak?
Given enough time, yes.
Given enough time, but under your current system, you wouldn't be testing for that.
It's unlikely, but not impossible.
But my question is that what you're doing right now?
It is possible we would detect that leak that you're talking about, a 0.1 gallon per hour leak in our current testing environment. It's not a guarantee, but it is possible.
Okay. Thank you. Then moving on to sort of a little bit more about the tanks themselves, you indicate in your testimony that you think that you consider the tanks to be steel, which is clad or jacketed in concrete. Can you describe what you mean by clad or jacketed?
When the tanks were initially constructed, the way they were built was with a 1/4 inch steel liner with 1/2 inch in the base plates and built up. After that, they poured concrete lifts behind the tank. So effectively, when you think of the mountain itself, you go basalt rock, and then you go the spray-on gunite, which is our name for shock creator, which you line a pool with, and then you have the concrete that was actually poured. Then there's a thin layer of pressure injected grout, and then there's the actual steel liner itself of the tank. That's how I would describe the clad or jacket effect of it, in that the steel liner is there to act as an inherent barrier to release. However, it doesn't have to absorb the force of the fluid in the same way a traditional tank would. In an above ground storage tank, the fuel simply sits pressing up on the steel, and that expands outward. So the tank expands and contracts. That's not true of these tanks because they're buried underground. So the force, the force of the fluid and the pressure it exerts presses on the steel, which presses on in this case, the pressure injected grout, which presses on the concrete, which presses on the gunite, which presses on the mountain itself. So the structure itself is really encapsulated the mountain because they never impacted the structural integrity of the mountain when they built the facility. That's how I would describe the steel jacket or clad effect that you're talking about.
So it's really a structural thing. It's really there to support the structure of the steel. Is that accurate?
Yes.
So it's not necessarily a corrosion controlling method. It's actually a structural method.
It acts as a corrosion control method as well.
In
Because the
order
steel is-
in order for it to act as a corrosion control method, does it have to be in contact with the steel?
Not necessarily, but that would be helpful. What you're looking for is when you go to regulations and Hawaii administrative rules, as well as the EPA regulations, you're looking for steel in contact with the ground. That's when you begin doing cathodic protection and other mechanisms, right? So even if there you get a gap or a seam, it's still better than the steel being in contact with the ground itself.
But can't there be other elements that cause corrosion, not just the ground? Isn't
Yes.
that why that the Hawaii administrative rules actually require UST tanks that are underground to have corrosion protection? I mean, even if they don't come in contact with the ground. For the pipelines, they require it to be in contact with the ground, but not the tanks. And my understanding, and correct me if my understanding is wrong, is that's because there are other elements that can cause corrosion.
Yes, I would agree that there are other elements that can cause corrosion.
And one of those elements would be the presence of water, correct?
Yes, water can result in corrosion on steel.
And are you aware of the fact that there has been water seen on the backside of these tanks?
I'm sorry, I'm not sure what you're referring to.
So the backside of the steel liner, for example, when the destructive testing was done and those coupons were removed, my understanding is that there was water seen on the underside or the backside of the steel, the part that you don't have any corrosion protection on. Is that consistent with your understanding?
I saw the plates after they were removed and brought into my office immediately after. I saw no moisture on it, other than one that appeared to have from the lower dome had a what I would call a coating on it. That's the only one that may have had moisture that I'm aware of. But I believe you have Mr. Frank Kern coming up, and he was there when they actually cut them out, so he'd better be able to speak to it than I. But I didn't see any moisture on the plates.
We will discuss that with Mr. Kern. Thank you. So again, would you consider? Do you believe that the concrete is in contact with the steel throughout the Red Hill facility?
I believe overall, yes. However, it's impossible to prove a negative. So I can't say for certain that in all 14 currently operating tanks, 100% of the steel is in contact with 100% of the concrete. It's acceptable to believe that there has been some pull away over time, but I wouldn't believe it to be anything large. I mean, we're talking millimeters, if at all.
So you testify that as a fuels officer, one of your tasks is to make sure that this facility is operated safely with regard to human health and the safety of the environment. In this critical role, can you explain to us what you would do in the event of a catastrophic release? In the event of a catastrophic release, I understand what you're saying, but could you better define the catastrophic release? What scenario are we talking about? Let's say if there was 1 million gallons released, what would you do? Where is the release occurring from? Tank 14. Tank. What part? Any of the tanks, but let's just say tank 14. I'm not. I apologize. I'm really not trying to be difficult here, but the tanks are constructed in such a way that the tank envelope itself, having a catastrophic release from the tank envelope itself is, I mean, almost, I don't want to say inconceivable, but very challenging. If you could give me a better explanation of what kind of release you're talking about, I could, but a catastrophic release just from the tank envelope, the probabilities of that are negligible. There's evidence that there's corrosion happening, that these are aging tanks, that we all know that corroded steel can be subject to failure. I mean, you see that bridges sometimes fail because of corrosion, buildings sometimes fail because of corrosion. So it doesn't seem to me to be an inconceivable scenario to say that you could have a failure of the steel in one of these tanks. And I'm giving you just a range to say, let's say there was a million gallons. That's one of the things that your the ABS report considers. So if there was a release because there was some failure within the tank that allowed for the release of 1 million gallons of fuel, you certainly have way more than 1 million gallons of fuel stored there. What would you do?
Again, that's not something that's realistic to practicable. I understand that corrosion is occurring. I'm not denying that corrosion occurring, but what you're describing, that's not how corrosion occurs. It's simply not realistic that the tank envelope would have a catastrophic failure from corrosion that result in a 1 million gallon release.
So when your own expert said there was a 5% chance of a sudden release of more than 1 million gallons from Red Hill in the next 100 years, they were talking about an impossible scenario?
I'm not saying they're talking about an impossible scenario, but you define Red Hill, you're talking about the tank envelope itself, or are you talking about the entirety of the facility? It's two very different things, and I apologize.
If you can't answer for the one tank, then answer for the whole facility. Answer for whatever you can answer for. If whatever ABS was talking about is being possibly happening, what would you do in the event of a release of 1 million gallons from Red Hill?
So I believe what you're talking about when you refer to that isn't the actual failure of Red Hill tanks itself, but it's actual the connection or the piping, which has always been the most likely scenario for a catastrophic release, not the tanks, but the piping and the connections in that system that is identified as the most probable cause of a large scale release. In that case, the upper tank, based on the 1998 Will Brothers report, we installed security doors as well as tank caps over top of the Red Hill water shaft for any intrusion, even though the modeling shows nothing would ever reach it. And the door automatically shuts when it detects petroleum or other fluids of a POL nature to lock down the tunnel and secure the tunnel from rolling downhill.
And you could hold 1 million gallons of fuel in the lower access tunnel?
Yes.
And before you got the door shut, if there had been a release into the environment, what would you do then?
There's several miles of tunnel between the door shut and the actual downhill run. So there's collection points downhill from the shutting door that you can station vac trucks and other technology to suck up any fuel that passed by the door. We practice that regularly.
You practice that for like 1 million gallons fill?
So there's a release practice event effectively mandated by, and I'm forgetting the acronym for it, but effectively you practice for 3 different events. Each year you practice for a different event. So the first year you practice for, let's say a small but likely, more probable but larger, and then the worst case scenario on the 3rd year, and then you repeat the cycle.
There is discussion that there's a recognition that there could be a large fuel release into the ground that would necessitate treatment to be done. That's been called out as being something that is certainly feasible, if not probable. What would you do if there was a large amount of water fuel released into the groundwater?
The intention of the Navy, I believe, is to continue to forward on the path to build a groundwater treatment facility in order to treat any large-scale release of fuel.
If that happened tomorrow, what would you do?
You could run the pumps from the groundwater facility, pull the fuel up from the actual using the Red Hill pumps, and then send it down to a wastewater treatment facility. But you'd eventually run out of ability to do that. So you'd have a limited time you could conduct that.
And you have those arrangements in place so that you would have some place to send it to immediately if it happened tomorrow?
I believe so, yes. I'm not an expert in the wastewater treatment facility and other locations in the Navy, but because of the location of the Navy's Red Hill shaft, you could pull up that water. And we do. I mean, 20% of the joint basis drinking waters come from that shaft.
I don't remember seeing anything about sending it off to a water treatment facility in any of the Navy's testimony. Are you aware of where in the record that is?
I'm not. I don't know. I don't know if it's ever been fully fleshed out, but that's what I would recommend in that scenario.
Okay, but you don't know that that's actually something that's in place or could be carried out. As the chief safety officer, you don't have that plan.
I'm sorry, the chief safety officer?
I'm sorry, the fuels officer, who is one of their tasks is to make sure that the environment is protected. In that role, you don't have this plan.
That'd be a NAVFAC facility, not a FLC Pearl Harbor facility.
Okay. So you note that that you've been conducting the inspections according to the decision document from the administrative order. Do you agree that it's critical that that inspection continue to be carried out on a regular basis?
I'm sorry, you're saying in regards to the term report, the tank inspection,
Yeah.
repair, and maintenance report?
Yeah.
Yes, I believe that inspections are critical to the facility.
And do you think it's acceptable to have the inspections occur more than 20 years apart?
Trying to backdate a standard for today's API 653 standard and fit into the historical practice of the facility is always going to be exceptionally challenging. The standards in 1950 or 1960 or even 1970 aren't 2020 standards. So to say that you're going to apply that standard to historical practices is challenging.
Have you met the 20-year standard since it's applied on all the tanks?
No, we have not.
And do you believe that's acceptable?
No.
Just a couple of other questions back about your leak detection. From the time that the alarm would go off, how long do you think it could be before you would start draining the fuel if you figured out it really was a leak that was happening?
Depending on plant configuration, a matter of minutes to hours.
All right, well, I appreciate your taking the time to discuss this with me. That's all the questions I have for you. Thank you.
Thank you, Ms. Fuller. Ms. Gammon, I apologize.
Mr. Frankel?
All right. Commander Whittle, you don't live on Oahu, do you?
I don't anymore, no.
On page 26 of your testimony, you talk about what the draft permit authorized. Let's take a look at exhibit N-38, if I can figure out how to share my screen.
I apologize. I wasn't I was told I wasn't allowed to bring any resources into this, so I don't have my exhibits with me.
That's fine. I'm going to try to pop it up here. I can figure out the technology. All right, hopefully, is N38 visible to you?
And yes, sir, Mr. Frankel, is that acceptable for a form of address?
You can call me Chemo, but that's whatever you want to call me. Sure.
Yes, sir. Yeah, I see it.
Okay, so this document, this draft permit, it's not signed, is it?
No.
It's not dated.
It's not fully dated, but they issued what the month and the year when they provided it to us.
And there's a couple X's there, right, in the date.
Yes.
So it's not fully dated. It's a draft, isn't it?
Yes, I believe it's marked draft at the bottom.
It did not authorize anything, did it?
The draft permit?
This draft permit authorized nothing.
As I
Correct?
remember, yes, but the draft permit was attached to a letter allowing us to continue to operate the facility. I apologize for not being allowed to have my exhibits, but I believe that's one of the other attachments, that letter.
That letter was not attached to this document that you're
I
referring
apologize
to.
then.
Okay, and we can address that letter at a subsequent time. All right, let's Let's talk about leaks from Red Hill tanks and associated pipelines. They've leaked in the past, correct?
I didn't hear the question.
They've leaked in the past.
Have the tanks leaked? Yes, they
They've
have.
leaked. They leaked in 1948.
I don't have a record of every incident you're going to refer to in front of me, and I apologize for that.
You ever see the Bechtel report?
Yes, I'm familiar with the Bechtel report.
Is it consistent with your memory that back in the late 40s, the tanks leaked based on the Bechtel report?
In the 40s, in the Bechtel report, it does refer to leaks. However, after studying the facility and going through those reports and early data, it appears that you can't determine what is a leak from the facility versus was a leak originating from the telltale system. Therefore, you can't tell if that release was released to the environment or was released into the telltale system and drained off into a slop tank or other mechanism.
Okay. The tanks leaked in 1998, is that right?
I've never seen any proof or record of that. In 1998, we filed, I believe you're referring to the report the United States Navy filed on one of the tanks. However, that tank was subsequently drained down, inspected, and put back into service. That was before tank tightness testing, as well as before the current installation of AFHE. So getting determination of any leakage before that time, or around that time, is very challenging. There was no technology for tank tightness testing like we do it today. So I've never seen a confirmation of that report. I know there was an initial notification to the Department of Health that we believe we may have an issue here, but when drained down, they couldn't find any hole in the tank or other issues that I'm aware of.
Are you aware of the Wilbros engineering report?
Which one, the 1998 report?
Yes.
Yes, I'm aware of that report.
Are you aware that in that report that it noted that there are fuel leaks during normal operation?
I'm aware of that statement. However, I'm unsure of what they meant by that. Fuel leaks during normal operation is not consistent with the facility I ran nor anything I ever saw. So I can't understand where they got that from.
Okay. Tank leaked in 2014, right?
That's correct.
And one section of pipeline was found to be leaking as recently as January 2019.
I believe you're referring to a part of the network, but not a piece of pipeline that is in Red Hill proper. Are you being, in general, referring to the entire Defense Fuel Support Point? Or are you referring to the Red Hill facility, its actual self?
Well, you helped prepare the application, correct? That was submitted to the Department of Health to operate these these tanks?
I did.
And as attached to your application, you included a report on a section of pipeline. Do you recall that?
I believe so, yes.
Okay, so that pipeline is part of this application, correct?
That's correct.
And that pipeline was found to be leaking as recently as January 2019.
But that's not attached to Red Hill. That's a pipeline that attaches to the upper tank farm located on Pearl Harbor proper.
You included in the application, didn't you? For this
yes,
permit.
that was the requirement to include it, but it was not part of Red Hill proper. It's part of the permit for the entire facility.
Right. It's part of the permit for the facility, which is the subject matter of this contested case hearing.
I understand what you're saying, but that pipeline didn't fail in Red Hill or near Red Hill. It failed due to best business practices because it was not an actual regulatory requirement to test that piece of pipeline on Pearl Harbor.
It was leaking.
It was not leaking. We pressure tested it, and when it pressure tested, it failed the pressure test. That's how you determine in the POL industry if you have an issue. You go above the correct operating pressure. You go up to what we might call the max allowable operating pressure, and using pumps to pressurize it, then you closely monitor it. That's the system that the industry uses to determine pipeline integrity. In this case, the pipeline did not pass that test.
And therefore was vulnerable to leaking.
Yes, and taken out of service.
And there are 4 other sections of that pipeline that also had failed test previously, correct?
I'm unaware of any offhand, but I know there have been failures of the pipeline. That's why you test it.
Okay. Now, Navy leaks have contaminated our groundwater, haven't they?
I'm sorry. I don't fully understand the question.
Leaks from the Red Hill facility have contaminated our groundwater, haven't they?
I wish I could better speak on the subject. I'm not an expert in groundwater. To the best of my knowledge, there have been elevated TPHD readings directly underneath the facility. But my understanding is that's a breakdown of constituents that are being detected there by the biome. But again, I'm not an expert on groundwater, and I apologize for not being able to more fully answer the question.
If various Navy reports, which the Navy has actually submitted as evidence in this contested case hearing, say plainly that the facilities contaminate our groundwater, you have no reason to disagree with that, do you?
I'm not sure what reports you're referring to, but if those are the Navy's reports, then although I didn't sign off on them, I can't speak to them very well, and I apologize for that. I don't know what to say.
All right, well, maybe we could look at a few. Let's see if I can do this. So this is Exhibit B8. It's the final Red Hill Bulk Fuel Storage Facility Technical Report from August 2007. The big block of yellow there, the last sentence of it says, 3 groundwater monitoring wells were installed within the lower access tunnel of the facility, and samples from each have consistently detected petroleum dissolved in the groundwater beneath the site. Do you see that?
Yes.
Do you have any reason to disagree with that statement?
No. I don't know who did this report in 2007, but I have no reason to disagree with that statement or that report.
Okay, here's the 2010 audit prepared for the Navy by, I guess, some branch of DOD. And it says, this is Exhibit B11, page 2, fuel releases, site investigations have shown evidence of fuel releases which have resulted in contamination of the rock bed, soil, and groundwater surrounding the Red Hill tanks. Do you see that?
Yes.
You have any reason to disagree with that?
No, not that I'm aware.
Okay, and we'll conclude with this one, which is Exhibit S-5. This is not a Navy document, so we'll leave that one aside and we'll stop there. And your consultant concluded that these tanks are likely to leak again, didn't it? ABS.
During the risk assessment?
Yes.
I'm not a risk assessment expert, but I don't believe that was their fundamental conclusion. No.
All right. No further questions. Thank you.
Any questions from the EHA party?
Thank
yes,
you.
EHA, we have just a couple questions for you, Commander Whittle. Page 15 of your testimony, in response to a question about how were the regulating agencies involved in the Navy's development of its application, you indicated both Department of Health and to a lesser extent the U.S. Environmental Protection Agency were involved. But you're not contending that the EPA is part of the DOH permitting process, are you?
No, simply that we did a working call every single Monday that I was at the facility. with the EPA and Department of Health, or virtually every Monday. And during those discussions, the permit was often discussed during that period of time, whether us giving updates or requesting updates or them requesting information from us. And the EPA and Department of Health were both on those phone calls as our regulators. So I believe that they were aware of it, but it's a state permitting process. So the EPA had a much lesser role than they do in many other aspects of the AOC.
Okay, and then along those lines, on the next page of your testimony, you indicated that the majority of the week before the permit was submitted was spent in meetings with the EPA and Hawaii State Department of Health, and that the Navy brought copies of the permit to the room where they were having the meetings to review. Would it be correct to say that those meetings were actually on the AOC?
So if memory serves me correctly, in July of 2018, the HAR was amended to require the permitting of the facility. Knowing that was coming, we began meeting with the DOH in anticipation for that. That permit form, in my opinion, is designed for gas station facilities, much less complex than this facility. And so I believe early December of 2018, we hosted DOH for several days to walk through the facility and discuss the permit application and the permit itself to make sure we're complying with all regulations before we even started the application process. Then in early 2019, we began the actual application process. During the week of meetings face to face, there was many topics discussed, but as I remember it, Captain DeLeo, who is then commanding officer of NAVFAC Hawaii, walked into the meeting with the permit itself and announced that this was the permit that we would be submitting. And I believe we submitted that day or the next day. We didn't directly hand it over to them, but certified mail, send it to the Department of Health. I'm not sure if that fully answers the question, so I apologize.
No, I was just wondering if the focus of the meeting, is it your testimony, the focus of the meeting the week before was on the permit, or was the focus really on the AOC destructive reporting, groundwater model updates, those type of things?
In my mind, from my perspective, it was an AOC week of face-to-face meetings. But what's inside the scope and outside the scope of the AOC, things like the permit, which the AOC doesn't directly address, were still discussed because you had a meeting of our regulators and the regulated body there. So I don't think we could exclusively say that it was only AOC discussion, because it was, in my mind, anytime we met face to face, it was, well, you're our regulators and we seek guidance, or we want clarification, or we want a process check on how we're doing.
That's all the questions I have. Thank you.
All right, is there any redirect?
Definitely. We'll request to take a break at this time and then come back for redirect.
That'd be fine. How much time would you like?
15.
We'll do 15 minutes.
All right, we will take a 15-minute break.
Thank you.
Commander Whittle, if you can just stay logged on. Sorry, sir, just stay logged on, and you can pause your computer so we all stay logged.
Do you want to go into a conference room?
Oh, no, sir, not on the Zoom. That's not necessary.
All right. We'll see you in 15 minutes.
Okay, quickly.
Wanted to check in with you. Is everything going okay? Do you need anything?
Were you talking to me?
Yeah, I wanted to check in with you. Are you needing anything? Any?
No.
Requests?
Not
Okay.
now. Yeah. Thank you.
And do we have everyone back who needs to be back?
Everyone except the witness. Oh, here we go.
Okay, critical. All right, Ms. Minot, are you ready to begin?
I just have a quick question.
Okay. We're
think
not
she
on
turned-
record yet. We're not on record yet.
Okay.
Well, no. Oh, you want to be on record? We can go on record.
Yeah.
All right, back on the record, please.
I just want to establish for the record if anybody's in the room there with Commander Whittle, who's not already in our Zoom gallery here.
No, I'm in my house in Virginia Beach, and I told my wife and daughters they had to go somewhere else. As much help as my 3.5-year-old would have been for this, so I'm all alone and have
Okay.
spoken to no one.
All right, thank you. Ms. Minot.
Yes, thank you. Commander Whittle, wanted to follow up on a couple things from your testimony here from the cross. How has the alarm protocol changed since 2014? What are kind of those processes or procedures that have changed since 2014, since the fuel release?
In 2014, a very different procedure was in place. The operators themselves, the control room operators, if you've toured the facility, you've seen the control room, and 24 hours a day, 7 days a week, a PAPA sits there. A PAPA had the authority to silence alarms on their own. No longer is that true. Any alarm automatic resulting to a routing to the operations supervisor, to the deputy fuels officer, and to the fuels officer for immediate notification of any unscheduled fuel movement or other alarm. In addition, we audit the logs regularly to make sure no alarms were missed. There is no ability for them to dismiss or make a judgment call on their parts. That would be the single largest way we've changed the way we react to alarms since 2014.
And Commander, does the Navy have a groundwater protection plan?
We do.
I would like to go ahead and bring up B373.
Is that the? Oh.
Commander Whittle, do you recognize this document? Are you familiar with it?
I am.
And what is it?
It's a groundwater protection plan for the facility.
And does this contain actions that would be recognized to remediate a large release?
Yes.
Thanks. I would also like to bring up Exhibit N41. Commander Whittle, do you recognize this document?
Could you scroll down? Yes.
And what is this document?
After we submit our permit, that was feedback provided by the Department of Health It states the Department of Health considers Navy Region Hawaii, in short, the Navy submission of its application for permit is timely. Based on this, the DOH intends to allow the Navy to continue to operate the subject UST system until its decision on the permit application is rendered. In this case, application for the Red Hill bulk fuel storage facility.
Great, thank you. No further questions.
Great. Any recross from any parties first? Board of Water Supply.
That's a lot.
I do have one follow-up question. So when we were talking before about what you would do in the face of a catastrophic release, you couldn't identify the actions, but now you were just pointing to a groundwater protection plan. Is that plan still current and in date?
I'd have to check. I've been away from the facility now for 6 months as I'm at Navy Expeditionary Combat Command here in Virginia Beach. But to the best of my knowledge, it receives regular updates and it has been updated.
The version that just put on the screen said it was updated in 2014, I think. So that would be the regularly updated?
I believe so. That was the most current version, but I'm not a specialist in the protection plan, so I couldn't say for certain if it's been updated since then.
So that plan hasn't really changed since the release in 2014 of Tank 5?
The groundwater response plan?
Yeah.
I'm not an expert in it. I can't speak to that. I'm sorry.
Okay. And so again, you indicated that you knew that this plan existed and you're aware of it. My understanding is that it's supposed to be updated every 5 years. Is there any reason that doesn't sound accurate to you?
I'm unaware of the regulations for updating the groundwater protection plan.
Okay. And again, since in your role as one of the people supposed to be in charge of the safety of the environment, so what would you do according to this plan in response to a catastrophic release?
I have to go through.
If there was a release into the groundwater, what would you do?
I have to go through and review the plan and go through it. Again, I apologize. It's been 6 months since I ran the facility. I'm not as current as I should be. I'm focused on my current job now. So I apologize, and I don't operate a fuel facility anymore.
Okay. That's all that I had. Thank you so much.
Mr. Frankel, any recross?
Yes, just to give Jay Page a little heartburn here. So that July 2019 letter that Keith Kaoka signed that you were just asked about, you don't know whether the Department of Health had legal authority to suggest to the Navy that it could operate the tanks until a decision on the permit application is rendered, do you?
I'm not an expert in the state law of Hawaii. However, they are who we go to as regulators. So I assume if they gave me regulatory guidance, it would be correct and true. And I operated the facility as such.
Okay. Thank you. No further questions.
Okay. Mr. Page, any questions?
No questions.
Okay. I have a few. Commander Whittle and councils, this is early in the hearing process. So if my questions are better directed to other witnesses, by all means, feel free to call that out. You all know much more about the details of this case at this point than I do. So I'm just trying to understand some basic things. So my questions might be better addressed to other witnesses. And if that's the case, I'd like for you to let me know. First of all, Commander Whittle, I'd like to ask you to take a look at and help me understand the tank construction. And so I'm going to put up the exhibit that shows the tank. Okay, I guess I have to stop sharing that. Hold on.
No, I saw it.
Okay. No, I'm not seeing, are you all seeing exhibit N90?
I did momentarily and now it's gone again.
Okay,
saw it.
maybe. Okay, I think
We can pull it up, sir, if.
oh no, I have it. Hold on. Are you seeing it now? I'm seeing my old, my notice to the,
We see it.
Nope. I'm seeing the Red Hill tank exhibit.
We're seeing it too.
okay.
It also.
All right, hold on, something, let me fix my screen here. Okay, and, in looking at this exhibit, I've been trying to get a picture, an understanding of the tank construction. And so I'm glad to have this exhibit. One thing I notice is that there's supposed to be a 6-inch layer of a gunite covering on the basalt. And this exhibit does not show that. But is that your understanding as to how the tanks are constructed?
Yeah, yes, sir. I can run you through it quickly if you want to help make it more sense. I think this diagram has been simplified slightly for purposes of illustration. But imagine that the ridge line is about, in your imagination, where the Red Hill tank exhibit exists, where that's how much dirt is above the tank, right?
Right.
So when they started to build the facility, they did two things at once. They knew they had to dig the tunnel. So they started on the lower access tunnel down at Pearl Harbor. And they also started up at Red Hill, and they dug that center towards the tunnel. So that would be the lower access tunnel you're looking at. Once they completed that tunnel, at the same time, they were drilling from the top of the mountain, a 4-foot by 6-foot, I would call it pilot shaft that reached from basically where the Red Hill in your mind is down to the top of the tank, and then went from the top of the tank to the bottom of the tank, and then actually about 15, 20 feet below that. In the diagram, that's where the center tower is the same place where they built that pilot shaft. Then at that point, they actually dug in from the side as well, from the upper access tunnel and lower access tunnel to connect the entire system. Once they dug in from the upper access tunnel, they dug a what they called a ring tunnel around the outer edge of the tunnel. Now, it's a little bit hard to imagine in this diagram, but imagine when you walked into the tank, if instead of walking straight out, you walked left and right around the tank, and effectively that created a ring around the outer edges of the tank up at the upper access tunnel. Then from there, they cored up to that top center shaft and then lowered down effectively the metal plating you see to protect the workers from rockfall. And then they hung scaffolding 360 degrees around the outer edge of the tank at that level on about 15, 16 wooden hand cranks. And what they would do is excavate out to the depth that they needed and then lower it down a few feet, go down and keep on going all the way to the bottom of the tank and about 20 feet below the bottom of the tank. So then at that point, they'd excavated the space that they needed. But as they were going, to your point, they used grout. Grout, that's not a good term. They used spray-on gunite was the term at the time. You'd call it shotcrete today. And that provided an initial 4 inches to 6 inches of coverage on top of the rock. That was to consolidate the rock as well as to keep down the dust during construction so they could continue to work their way down. So as they excavated to the depth, spray on that gunite, and then go down to the next level and continue your excavation down. So yes, there is a coating. The first thing touching the actual basalt rock is spray on gunite all the way throughout the entire tank envelope, basically. Does that answer the question, sir?
It does, very helpful. Does the gunite go under the tank as well?
Yes, the gunite goes everywhere for consolidation, to the best of my knowledge. They sprayed it down over all rock surfaces, to the best of my knowledge.
Would the gunite also go above the?
Absolutely.
Tank? Okay, so I'm understanding then the construction was it was a mined operation. You were
Yes.
excavating like a mine. You were not working with a pit.
No, so think of it this way. As they excavated out on that harness I talked about, on that 306 degrees of scaffolding, it fell down that center pilot hole, expanded out to 30 by 30, about a 30 inch, and not 30 by 30, but a 30-foot diameter hole. They call it a slop hole. That fell down to the bottom of the tank where they installed conveyor belts. And actually at the time, the world's largest conveyor system conveyed the rock from underneath the tank all the way down to Pearl Harbor proper. So that's why they talk about it as a mined operation, meaning that that rock, one touch, you jackhammer it, you pickaxe it, it falls down that hole all the way down to the base and then is carried away. And that's why it's referred to a mined operation. Very different from other types of tank construction.
Okay. And then you use the term, the construction of the concrete shell around the tank. You use the term that the concrete was placed in lifts. Can you explain that process?
Yes. So if you were pouring a concrete sidewalk, say, you would put 2x4s up on either side of the concrete to contain the concrete as a mold for the concrete. Then you would pour it into kind of that form, you would call it, for the concrete. In this case,
one other term that was used was reinforced concrete. So do you know what the reinforcing was?
Yes, absolutely. It's a rebar woven throughout the entirety of the concrete. That's what accounts for the reinforcement.
So somebody had to construct then the form for the concrete.
No, because the form for the concrete in this case is the gunite we just talked about.
Right.
And on the interior of it, that's the exterior form. And on the interior form, it is the steel itself.
All right. So somebody then placed the reinforcing steel, and then you installed the concrete.
Yeah, you would build up the steel above a certain level, and then you would pour up that lift I talked about, allow that to dry, and then you continue to build, basically.
All right, I understand. The pressure grouting. Do we know whether it is a complete skin or shell, or is it spotty?
I couldn't say with any degree of certainty the pressure grouting goes everywhere. But I don't think I've properly explained where the grouting is in the process, and I apologize for that. Just before they poured that concrete, they did one last thing. They painted the basalt with red dirt, and we have pictures of them doing it with paintbrushes and spray guns to put red dirt on it. And that is a cleave area, right? Because as the concrete dried, it broke away from the mountain where that red dirt was, because it gave it something to cleave off of that it wouldn't stick to, and came towards the tank. So the grouting nozzles went through the steel liner, through the concrete, and into that gap that resulted from the drying concrete. So to fully explain it, it would be steel liner, concrete poured, grout, tiny bit of red dirt, and then gunite, and then basalt rock. And I apologize for the lack of clarity on that. That's a clunky explanation. I had so much trouble explaining this when I was in the job that I made up a styrofoam mock-up so I could point to it to explain it to people. And I'm sorry I don't have my styrofoam with me today.
That would have been good to see. So I have this. I have the layers then: steel, concrete, the
pressure injected grout,
and then the basalt,
gunite, and then the basalt.
Okay.
And again, I apologize for my explanation.
All right. Now the concrete completely encases the tanks.
Yes.
Does the grout also completely encase the tanks?
Yes,
Does-
but it's not touching the steel. It's touching in between the concrete. Actually, I can't say that I retract that. I apologize. That you can't say that the pressure injected grout completely encases the tanks. It simply went into the space where space was available when the concrete dried.
Okay, the gunite completely encases the tanks.
Yes.
All right. As does the basalt.
Yes.
You gave me the impression that in terms of weaknesses in the system that might contribute to an undesired release, that it would not likely be the tank, but more likely be other aspects of the facility. Is that your feeling?
Yes. On any large scale, the tank is unlikely to have a large scale release. I think the 2014 case is an anomaly because it wasn't due to corrosion or rust. It was due to impact to improper maintenance procedures, which we've since corrected, and that contractor has been bankrupted for the work they did. The risk is in the system, is the connection points to the system, not the actual tank envelope itself. That's why one of the largest risk reduction procedures we undertook upon the understanding the data in the report was to reduce it from 2 nozzles to 1 nozzle for the tanks, because the larger nozzle is fully man inspectable. A human being can crawl through it and inspect it. I mean, I did it once, and I wouldn't recommend it as a pastime if you don't like tight spaces. But the smaller nozzle you can't get into, so we're decommissioning that nozzle, and you can change its use and turn it into what's called a dry carrier pipe and route sample taps or whatever you want through the smaller nozzle. So there's effectively a double wall there for future use, if that's the route you choose to go.
Okay, and I think you might need to explain that a little more for me, but a preliminary question. The tank is fed in and out through the piping at the base of the tank. Would that be right?
That's correct.
All right.
If someone were to visit the facility, what they would, after being in the control room, they would look out and see the pump house. Those pumps are in place to push the fluid up that gradient to Red Hill itself, because you have to overcome that pressure in the tank as you raise it up. So you can only feed it from the bottom. Effectively from the top, the access that most people who've been inside the tank go in that manhole, that's for access for maintenance procedures when the tank's drained down. And the top is for ventilation and gauging at the very top of the tank, where you can see the gauging gallery label on top of it. But the only way fuel ingresses or egresses from the facility is through that lower nozzle piping.
Okay. Now can we talk about the 2014 release?
Yes, sir.
I have not seen a complete description of what happened. Are you familiar with what happened?
Yes, sir.
And can you tell me what happened? Where did the leak occur, and the like?
So as previously stated, we know tank 5 was not leaking prior to its maintenance, because although we were only doing it every 2 years, as it wasn't required by anybody at the time, we happened to do a tank tightness testing event a few months before tank 5 went out of service for its scheduled inspection. Once you inspect the tank, I believe, I'm sorry, ma'am, Ms. Gannon referred to it, you hang workers in baskets and they scan the entire interior of the tank, all the way from the top to the bottom. In that, you'll receive anomalies in the tank structure itself, the lining. And the idea is that you don't cut out the steel, because that weakens the tank, but instead you improve the tank by adding more steel inside. The short hymn for that is effectively a patch plate that you would put inside the tank. But before you can put the patch plate on, you have to weld it in place. In order to weld the tank, because it's a POL facility, you have to first have an inspector come in and drill a small hole through the actual tank line and take a reading behind the tank to make sure there's no explosive gases, because you're going to do hot work or welding and you don't want an explosion to occur. In industry, you don't have to fill that hole. In our tanks, by our regulation, we have to fill that hole back in. By Navy's requirement, you have to fill that hole back in. In the case of 2014, they did not fill that hole that they drilled back in. Then they put a patch plate, which intention was to improve the tank, over top of the steel, which was no longer meeting our requirements or our standards. They did an improper weld job around the outside of that patch plate so that there was a mechanism for the fuel, once filled, to go through that bad weld and through the hole they had actually drilled through the tank itself to leave the actual tank envelope. That happened in more than one location. I don't know the exact number of locations because of the poor welding that occurred. So you can't point to one area of the tank or one problem with the tank in a certain location, because in fact, it's because where they did work, often the work was shoddy and it caused the release.
Okay. Thank you for that explanation. It's very helpful. There was also discussion though about operator error, and I think you talked about it in brief. That apparently the alarm system worked, alarmed that there was a release, but the operator improperly just shut off the alarm and ignored the alarm. Is that what happened?
Yes, sir, that's correct.
And you've described that the changes since have now removed that single operator decision point to a multi-level decision point. And stuff.
Even more importantly, sir, and probably I apologize for failing to do it, we don't fill tanks the same way. When we returned the last tank, we returned to service, instead of filling and waiting, we broke it up in smaller, more manageable, monitorable increments. We staged actual intermediary tank tightness tests during that process. So as you fill, you would do a few consecutive fills, very tightly controlled and monitored, and then you would wait, and then after another fill, wait again, and after another fill, wait again in small increments, and then stop everything, wait for the tank to fully settle, and conduct a tank tightness test in order to bound your risk better. So that way you're not testing the tank when it's completely full for tank tightness. You're doing it maybe a quarter full and maybe a half full and 3/4 full and all the way full. So that way each period, you know, if I had a problem, I could drain down to the last good level and know that the tank was secure.
Right. Jen, big picture wise, from 2014 till today, what are the differences today that address the problems that were encountered that led to the 2014 release? Besides what you've already told us about the operator multi-level decision making and the staged tank tightness testing, are there other differences today?
Absolutely. The first I would say is cost and investment in the facility. The cost to inspect and repair one of these tanks has increased literally tenfold from the cost of a 2014 inspection and repair in order to address the risk concerns, mitigations, and the standard of care of the tanks. I would say the oversight has completely changed. The last tank that was returned to service, I personally went out and viewed the weld inspections along with Commander Frame, the API 653 registered professional engineer who is it's his company who is certifying the tank, did that with us. The level, I mean, it's hard to even begin to describe the level of attention and detail that shifted from 2014 to today. To compare the operations then to now, it is almost, it's like comparing apples to lawn chairs almost. It's a very different thing. In 2014, you might be able to do an operation with little paperwork. One of the things we implemented during my time there, and John Floyd can talk about, is we never move fuel without a pre-planned standard operating procedure for every step of it. So we can make sure every single time we follow every step per the checklist to make sure we're doing it properly. We've changed the way we address risk. You heard earlier, we don't fill the tanks as high. What we found in risk assessments and inspections is the upper dome of the tank that you can see in that illustration, Mr. Chang, is the most challenging and problem-prone area. So in a normal tank, that would be the roof of the tank, and that's now how we treat this facility. Is instead of being what we would call wetted area or fuel sits, we treat it as a non-wetted area. So that way, if there are integrity issues in the upper dome, it won't affect the actual storage of fuel. That's just a few of the ways we've gone to address risk and reduce them. We talked about the decommissioning the nozzles, because that's a high risk point from the way the facility was operated. We are pushing forward with being, I believe, the first UST to have that certified tank tightness testing procedure in place. It's not done yet, which I acknowledge, but having that 24/7 will give us an incredible fidelity on the tanks itself. So it's a continuing process of improvements. My motto when I ran the facility, and what I would always tell my team, was we don't wait for the regulators to tell us to do something. We need to be one step ahead of them in trying to exceed the regulation. So we drove, while I was there, from going to an annual tank tightness testing to 2 tank tightness tests a year to make sure we are always exceeding the requirement. And that was the mentality. An amount of money the DoD is spending in some years, Defense Logistics Agency is close to spending as much money on Red Hill as it spends maybe for the entire United States Army fuel facilities or the United States Air Force fuel facilities. The investment and expenditure that we're putting into maintaining and modernizing this facility is huge and can't be understated. That's a lot of money putting into making sure the facility is updated and modernized.
Thank you very much. Coming back to the 2014 release, if up to 27,000 gallons of fuel was released, where did it go? Do we know?
Very hard to say. We publish monthly soil vapor monitoring reports. They're on DOH's website for people to go look at. And you can see a spike in soil vapor monitoring that occurs under tank 5 and around that time frame. So you can see some gets down there. But the analogy I use often is that you have to remember, although not a containment mechanism, the concrete works to absorb the fuel. I say it's a little bit analogous to if you're changing the oil for your truck or your car in your driveway, and when you're done, by accident, you kick over your spill bucket. You'll be able to pick up some of it, but a lot of it will be in your concrete or in your blacktop in your driveway until you remove that concrete, and that's where it'll remain. There's been a lot of study done on it, and it's very hard to say. So I wish I could provide you with a more exact answer of that 27,000 gallons, but that's the best I can say. So I apologize, Mr. Chang.
No problem. Okay, let's see if I have other questions. You were telling us about the installation of continuous monitors that has not yet been done. Is there a timetable for that?
I don't have the timetable offhand. When I left, I know they were pushing forward on that as of June of 2020. It's a little bit unusual. I don't know if a facility's ever done something like that before, so it's a little bit challenging. But I don't have the time frame for that installation, and I apologize for that.
Okay. You were asked a question about the TIRM and setting a 20-year standard that each tank has to be go through that process, but it has not been met. I wanted to find out, well, tell me generally, first of all, what is that standard? And then you can tell me why it has not been met.
The standard currently for how we maintain the tanks is American Petroleum Institute API 653 modified inspection. That's because the API 653 isn't intended for these tanks, which are unique tanks. Taking that standard, we have tank experts out at Expeditionary Warfare Center in Port Hueneme, and they put together the tank inspection, repair, and maintenance document in the term with a 20-year cycle. I think you'll see that very commonly throughout industry. Is 20 years is a very common time frame to go back and reinspect tanks, but that's condition dependent. It's also historically dependent. The challenge being is that you try and stay ahead of regulations. But for instance, if tomorrow they said, the regulators said, you have to inspect the tanks every 5 years, virtually all my tanks would then be out of periodicity. So as the regulations change, mature, and evolve, you're almost always playing a game of catch up to bring your tanks into compliance. So it's challenging to maintain those standards, as I don't think the API 653 and 20-year inspection cycle really came fully implemented until the early 2000s. So you're playing catch up to get back to the proper standard, because before you may not have been maintaining tanks on that same cycle. I know that's a little bit confusing and convoluted, so I apologize, but that's how I understand it.
Okay. One question in my mind is, has it been a recent change that has required the Navy to comply with the federal and the state regulations on these USTs?
Yes, and I'm not an expert on this, but I'll give you my understanding, and I think you'll have some experts that will come up later in testimony.
Right.
But as I understand it, the state of Hawaii has an approved enforcement plan. So what happens is the EPA under the region, in this case, Region 9 operating out of San Francisco, can approve any state of enforcement plan which meets or exceeds the EPA's regulatory standard. In this case, EPA updated their regulations, the CFR, and the following year that impacted, I believe, the Hawaii administrative rules, which are then impacted, and that's why the tank became permitted. The facility's been operating since 1943 with no requirement for permitting, and therefore was never permitted. I believe the EPA upgraded their, altered their definition of USTs as well as USTs connected to airport hydrant systems, and because of that, it was determined that we would submit a permit.
Is the pending application for a permit the Navy's first such application for permit?
For the Red Hill facility, absolutely. For other facilities, no. I'm sure there are other states where we have put in permits for facilities, and I know we permit facilities in Hawaii, but certainly the first Red Hill permit that I'm aware of. And yes.
All right. The next area of questions I have for you relate to the AOC. And counsels, if there are other witnesses that are better suited to respond to this, just let me know. But I wanted to get an overview of the status of the work under the AOC. It has 8 sections, and then, you know, is there somewhere which describes the current results? Because I understand it's been a multi-leveled moving process.
I could talk about that, but I believe the Navy has as a witness the AOC program manager coming up later in testimony. And Mr. Chang, he may be able to give you current fidelity and information on the AOC status, because I'm unfortunately a little bit out of date here. So I don't want to provide you anything factually inaccurate. However,
Right.
I will say the complexity of the AOC is that it's a continuous process. So oftentimes, although we're constantly working with the regulators, they're constantly visiting the facility or giving us guidance or interacting with us or reviewing documents, because it is a continuing process, our documents sometimes don't meet the standard the regulators require. And then we go back, review, improve them, make changes, and resubmit them. So it's constantly evolving all the time in the various sections of the AOC.
Okay, by chance, do you know the name of that Navy witness who's going to be more familiar with this?
I believe Mr. Don Panthen will be testifying on that.
All right, thank you. Councils, as a prefatory comment, there had been an article in the local newspapers that talked about or reported that the Navy has been investigating the feasibility of a tank within a tank option, and talking about plans or commitments to do such. Is that something that is going to be addressed by other witnesses, or may I ask Commander Whittle what he may know about this?
So Commander Whittle may have some information, but we do have 2 or 3 witnesses that may have more up-to-date information. Mr. Frank Kern submitted in his supplemental testimony that he is the kind of the technical lead for that effort. And then, as Commander Whittle said, Mr. Donald Panthen, he's the program director for all of the efforts done under the AOC. So he'd be managing, the business side of that. And then Commander Daryl Frame, who also submitted testimony, is familiar with the effort and the feasibility study.
All right, very good. Then I will spare Commander Whittle questions on this.
I appreciate that, Mr. Chang. I'm happy to give you my takes on it, but again, I'm a little dated, and that's a newer moving effort.
All right, very good. Thank you very much, Commander. Let me turn to councils again. Any further questionings as a result of the questions I asked? For the Navy, any questions?
No, we don't have any further questions. Thank you.
And for BWS?
A couple of questions that come to mind during your questioning. First off, Commander, when we were talking about the likelihood of where a release will come, I just wanted to clarify again, you were talking about the sort of the catastrophic releases are more likely to come from other parts than the tanks. How about chronic releases?
Chronic releases are more likely or as likely to come from the tank envelope as the piping itself. I would say chronic releases, you're at risk pretty equally everywhere.
Okay. And then the work that was completed that was done on Tank 5 that ultimately led to this, that led to the release. You had stated in your discussion now with Hearing Officer Chang that you were trying to put patch place over parts of the steel that no longer met your requirements. Why did those areas not meet your requirements?
There could be a variety of reasons it could meet the requirements. What I would say is that scanning technology is continuously improving. We used to use ultrasonic testing, now we use phased array ultrasonic testing. The analogy I give is if you went and got ultrasound because someone was pregnant 20, 30 years ago. It was a little bit hard to make out what the baby looked like. And now, because the technology's improved so much, you get a 3D ultrasound and the data is improved and you can get a better picture of what the actual tank looks like. Now, you can use a bunch of other technologies as well to scan it, but they've all improved, right? So as it's improved, you can now look at it and say, well, this weld, this patch plate might have made standards for when it was constructed in 1943. It no longer meets current weld or certification standards. So that's one reason. In addition, you could have thinning of the tank. Corrosion could be causing the tank to thin, and that's why our additional patch plate is required over top. That's anticipated in virtually any storage tank situation. And industry-wide, you're going to do patch plates in order to maintain the integrity of the tank envelope.
Right. So it's not really possible to say that the leak had nothing to do with corrosion. I mean, it's the reason that you were doing the repairs that caused the problem was corrosion, or could have been corrosion. Then it could have been related to corrosion. Is that correct?
No, I have to fundamentally disagree with that. We did a report that was a causal analysis of the 2014 release that was approved by the regulators, and the fundamental failing of the tank was holes were drilled through it. By my projections, that tank probably could have gone another 50 years without having any issues. But once you drilled a hole through it, you cause an integrity issue. Corrosion isn't the root cause analysis of that. It's the improper maintenance procedures.
Did you did a root cause analysis? Is that
I believe there was a report done, yes. Part of the AOC.
Has that been submitted as part of the evidence in this proceeding that we could look at?
I didn't submit that. I believe you can go on the EPA's website and it'll be on there.
I don't believe it's available, but so I just wanted to confirm. So that's not been submitted. And when you're talking about the way that you used to do these patch plates, was that kind of work and method only used in Tank 5 in 2014? Or was that method ever used in any other repair?
I'm sorry, I don't think I fully understand the question. Are you saying that patch plates are used in other tanks and other repairs?
Right, you were talking about how they did this grinding down and that led to these problems, and it was a process that you realized had to be corrected. Was that type of process used in any other tank?
The patch plate process is used in every tank in the world.
Right, but you were just criticizing the way the work was done in Tank 5. Was that type of work done in any other tank?
No.
So all of the earlier patch plates were done, you're confident they never were done in any sort of shoddy process, even though you didn't have this additional layers of quality control, et cetera, that you say now really addresses this problem?
I believe it was done by a different contractor under a different contract. That really comes down to a bad welder doing bad welds inside of Tank 5 that caused the release with the gas test hole.
But again,
yes, I don't.
But you didn't have these additional levels of ways to confirm that all the earlier repairs were done that you now say are in place. Is that correct?
That's correct.
Okay, and if there was corrosion that was continuing behind one of these patch plates and that created a through wall, would that result in a release?
No.
That couldn't result in a release?
No.
Okay, I have no further questions. Thank you.
Okay, Mr. Frankel.
Thank you. Can concrete crack?
Yes.
Are there cracks in the concrete surrounding the tanks at Red Hill?
I've never seen anything to suggest there is any. When we took the patch plates or any other time coupons have been taken, I've seen no evidence of cracking or spalling in the concrete that I'm aware of.
What percentage of the concrete has actually been looked at of the surrounding the tanks at Red Hill?
A very small fraction.
Thank you. When the fuel leaked out of tank 5, was all of it confined to that lower tunnel beneath the tanks?
I don't believe any of it actually ever entered into the lower tunnel beneath the tanks.
So it would have gone out. It went out into the environment.
Yes, or into the concrete.
Okay. Now, I don't know if we want to wait for, well, for those who are on the mainland, don't worry about it. This is just a regular test of our system. Don't freak out. There is corrosion on the backside found on the fuel tanks, isn't there?
Yes.
And there have been through holes found in a number of the tanks at Red Hill, haven't there been?
Yes.
Would you, when the tanks were initially designed and operated in the 40s, would you call them, were they designed and operated in a way protective of the environment?
For the standards of the time, yes.
No, the standards of today. When you talk about protective of the environment, were they designed and operated in a manner protective of the environment?
For a 2020 standard, no.
And
2021, sorry.
Yeah, that's fair. And how about in 2014? Were the tanks operated in a manner that were protective of the environment in 2014?
No, the failures of the 2014 release were not fully protective of the environment.
Okay. Were they protective of the environment in 2015? Were the tanks operated in a manner that was protective of the environment in 2015?
I don't know of any releases or any issues that were not protective of the environment in 2015.
I'm not asking if there are any releases. I'm asking if they were operated in a manner that was protective of the environment in 2015.
To the best of my knowledge, yes.
Okay, no further questions.
Mr. Page, any questions?
No questions.
Actually, there's one that was raised from your council's questions. The history of the leaks, there's a 35-year plus period before the 2014 release where there's no document indicating a history of release. Are you familiar with that?
Yes. When I initially took the job in June of 2017, to get a better understanding of it, I did a deep dive on all the files and all the historical reports I could find from the enactment of the, believe the Clean Water Act in '88 up through 2017, so I could make sure I had a full understanding of what I would say the recent history of the tanks.
A general question, why were there no documented releases in that 30+ year period when there were so many before?
I would say the preponderance of the prior releases, as best I could characterize them, would be falling into two categories. The first being ones where, although they were tracked as drops in the tank, it's unclear where the drop was coming from. These were the 40s and the 50s, where the telltale system appears to be malfunctioning because it was thin piping integral to the tank. So it could appear as release when release wasn't happening. Then you go into the early 80s, and it was maintenance procedures that were done on the tanks that were causing potential issues within the tanks. I think following, once you got into the 90s, the standard, although not acceptable for today's standard, the standard of repair and care on the tanks had improved substantially. And that accounts for why you don't see releases to modern day that I'm aware of, release reports, with the exception of 2014. Now, there were times that reports were made to the Department of Health. I believe I mentioned them earlier. However, when the tanks were drained down and inspected and refilled, there were no holes, no cracks, and no integrity issues with the tanks found. So I think the Navy has always leaned towards over-reporting on these tanks, regardless of if it turns out to be validated in the end or not. And so that's why you have some initial reports out there that are then followed up with later with here is for the regulators, here is the validated repair report showing there was no issue.
Right. Thank you very much, Commander. If there are no further questions, can we release Commander Whittle?
Yes.
All right. Thank you very much.
Thank you, Mr. Chang.
Would this be a good time for us to take a lunch break? We were the schedule called for us to go a little later, but do you want to start with the next witness and take a break, or would you like to just take a lunch break now and then pick up a witness later?
I think it makes sense to take a break.
Yeah, this may be a good stopping point, and we can line our witness up for whatever time we want to restart.
Okay. All right. How much time would you all want for a lunch break and breather? Is an hour good, or you want more or less?
We're happy with an hour, but
That's
All right.
fine. Yeah.
Let's go with that.
Can we start right at 1 as an even
Alright.
number?
yes,
All right. That's fine.
good idea.
Okay, we will recess for a noon break and reconvene at 1 o'clock. All right, thank you, everyone.
Thank you.
Thanks.
Thank you.
Hello.
Hi, this is Lou Chang. Do you know who a Kathleen Van, V-A-N, is?
No.
Okay, that person wants to join the hearing. I'm not familiar with the name yet, so I just was checking.
I can call Marnie. Would you like me to call Marnie real quick?
I just sent them an email, so she has just answered.
Hi, Mr. Chang.
Okay,
Hi.
she's answered, and it's fine. It's an assistant to the Navy.
Oh,
Correct.
okay.
I'm going to let them in.
Yeah, so yes, Kath Van is yes, that'd be great if you could.
Okay.
Yeah. So yeah, we'll try to let you know, but it basically be Razan that was on this morning, as well as Kath Van. Those are going to probably be the two main ones that will be assisting us.
Okay, no problem. I just didn't
Thank
want
you. Yeah.
somebody. Donna,
Yes.
everything okay?
Yeah. It's fine.
Okay, good. Are we missing anybody who needs to be, or who's handling the exam of Ms. Smith?
I will be here for the Navy.
Okay. So anybody else waiting for anyone to check in?
The board is not.
Okay, just a process check. Is everything going okay for you? Anybody need any changes to what we're doing?
No, I think we're pretty smooth so far.
Okay, and then one other question. I received a phone call request from the EPA representative in San Francisco, I believe, and she was asking for copies of the pleadings and exhibits, and I didn't feel quite free to just say yes and stuff. Any reservations or concerns or objections to providing some information to EPA?
I guess it seems a little unusual at this phase to have the request. You know, obviously a public record, and happy to have it shared, but should we wait till it's complete here?
Yeah, I think the official source for access to public records would be the Department of Health. So I could refer them to there, and then they can access it when it's available.
Who made the request? Is it something you can?
It was a Rebecca. Let me get the last name.
Rebecca Reynolds.
I think that's right. Yes, Rebecca Reynolds.
So the governor has suspended the Uniform Information Practices Act in his emergency proclamation. So it may be in part that, well, if you can direct the EPA to Department of Health, but Department of Health will not fulfill the EPA's request given the present emergency declaration.
Okay. All right. Okay, I just wanted to check in with you all on that. Okay. Shall we pick up then with the examination of the next witness from the Navy?
I have one question.
Yes.
When you were asking Commander Whittle just towards the end, you referred, and I thought you referred to some document which I'm unaware of, that talked about a 35-year gap in releases of from the Red Hill tanks.
Yes.
I'm not aware of that. That's a document in the record that talks about that?
It is, and it's the chart that shows the chronology, and it shows the circles in colors as to the size of the release. And so that just shows a 2014 event, and then the prior event isn't, for 35 to 40 years. So
what exhibit is that? You know the number? Okay.
I've seen it multiple times. I can't give you an exhibit reference.
If I can help, it's a figure, I think, that's found in Ms. DeNovio's expert report.
I believe that's correct.
Okay. All right, and as a matter of explanation to those who may be observing on the YouTube live stream, they may not be aware that we have agreed on a procedural process here where the direct testimonies of the witnesses has been handled by submission of written testimony, and we are concentrating the use of our time for cross-examination and for redirect. So just a matter of explanation to the possible observers. All right, why don't we go on? Donna, I didn't say on the record, but let's go. If not, let's confirm that we are on the record. And Ms. Riddle, you are calling the Navy's next witness.
Yes, Ms. Danae Smith.
All right, and Ms. Smith, may I ask you to take your oath at this time?
Yes, sir.
Please raise your right hand. Do you solemnly swear or affirm that the testimony you're about to give will be the truth, the whole truth, and nothing but the truth?
I do.
Thank you.
Thank you.
Ms. Riddle.
Yes, thank you. Danae Smith is the Environmental Compliance Program Manager at the Naval Petroleum Office. She's been in this position since October of 2013, and before that, she also held the position from April 2011 to September 2012. Ms. Smith, could you briefly summarize the content of the testimony that you've delivered so far in this case?
Yes. Good afternoon, everyone, or good evening if you're on the East Coast like me. I am going to discuss the Hawaii Administrative Regulations 111-180.1 for the underground storage tank regulations and how they apply to Joint Base Pearl Harbor Hickam, specifically the Red Hill field constructed tanks. And the previous deferral that was done in 40 CFR 280 that was removed in 2015, making the airport hydrant system at Hickam Airfield and the Red Hill field constructed tanks no longer deferred from these regulations. Over.
Thank you. Ms. Smith, are there any corrections you'd like to make to the testimony that you've already given?
Yes, on page 6, there was an error. I had cited just 20C with the piping, and if you could pull up the 20B for the tanks so I could read the correct statement. I was trying to be concise.
So can you see my screen?
Yes.
Is this the section that or the question and answer that you're talking about?
Yes, so this is the section at the bottom of the page. I had wrote HAR 280.1-20B and C state that routinely contains regulated substances and is in contact with the ground must be properly designed, constructed, and installed, and any portion underground, ...
Sorry.
No, that's okay. So that is tied to C, which is for piping. 20B, and just to shorten my testimony, I'll just say the end portion instead of going over 11 TAC 280.1, unless you all want me to say that repeatedly. Do you guys have a preference?
I'm sorry, one moment. I was going to bring up the,
Oh, I can state it. 20B, the tanks only says that tank that routinely contains regulated substances must be properly designed. So, and is in contact with the ground was not included in B.
got it. Okay. And I can bring up the HAR section. So we can take a look if you like.
Sure.
There we go. Should be it. Okay, so this is section 11-280.1-20. And then B is here. Can everybody see that?
Yes.
Okay.
Yes, so for B, it says each tank must be properly designed, constructed, installed, and any portion underground that routinely contains product must be protected from corrosion in accordance with the code of practice.
All right, and then C down here refers to piping.
And then the piping that routinely contains regulated substances and is in contact with the ground must be properly designed, constructed, installed, and protected from corrosion in accordance with the code of practice developed by a nationally recognized association.
All right, thank you. Your witness, whoever's starting.
And
For
give me
procedural, do you want
give me a moment. Witness is coming in. Let me admit the witness or the observer. I don't see them now. Okay. Ms. Gannon, are you conducting the cross?
I am.
All right.
But Ms. Smith, did you have a question first?
Okay.
I'm just going to mute my line and then unmute so there's less feedback.
That's,
all right.
That's fine. So good evening, Ms. Smith, and thank you for joining us to answer some questions that I have about your testimony. My first question is, can a facility that leaks, an underground storage tank that leaks, meet the requirements of Hawaii state law?
An underground storage tank that leaks has to do a few things. If it is leaking, we have to report it, and then a repair has to be done. And then if it's tested and passes the repair, then it can return to service.
So are you aware of the requirement in the statutory requirement in 342L32B? I noted that in your testimony you had referred to 342L and other provisions, but not this specific provision. But it states that underground storage tanks and tank system standards shall include but are not limited to the following specifications. And the first specification is the tank and the tank system shall be designed, constructed, installed, upgraded, maintained, repaired, and operated to prevent releases of stored regulated substance for the operational life of the tank and the tank system. Are you familiar with that provision?
Yes, you cut out the first part, but I heard the statute part, so I think, yes, I am aware of that.
So this provision requires that for the operational life of the tank system, they cannot be operated and maintained so that leaks occur. Is that correct?
So the tank is supposed to hold fuel, yes, and prevent leaks.
Right, they shall be designed, constructed, installed, upgraded, maintained, repaired, and operated to prevent releases of the stored regulated substance for the operational life of the tank.
Yes, yes.
So how does the Red Hill facility meet that requirement?
So we, first they were designed and constructed to prevent leaks, the original construction. All tanks are designed to hold fuel, not to leak. And then if, like it said in the statute, you can repair a tank if it has been found to be leaking, and then repaired to meet.
It does say it can be repaired. It doesn't necessarily say it can be repaired to address the leak. It's because leaks are supposed to be prevented. So are you saying that it specifically says you can have a leak first and then repair it and still be in compliance with the statute?
I think that the HAR allows for that.
I'm talking about the statute, which obviously, statutes in the way the law
Yes.
structure, statutes, regulations, right? So I'm starting with the statutes.
Yeah, so the statute, yes, the Red Hill tanks are designed to prevent leaks.
Have there been leaks at Red Hill?
Yes.
Have there been many leaks at Red Hill?
The last one that I know of is the January 2014 one, when we were able to reportably in the 70s to actually require to report. It was in the 2014 spill.
Right,
and we did.
Oh, I'm sorry, go ahead. I didn't mean to cut you off, sorry.
No, I said the Navy did report that release from Tank 5.
Okay, so that was in 2014. Are you aware of the ABS report that has been done on the tanks?
Yes.
And
Section
in the ABS report, there's a list of what they identify as known and verified leaks, and it's in the numbers of like 60 or something like that. So do you have any reason to believe that the ABS report is wrong about the fact that there've been a number of leaks that have happened over the years?
I'm really sorry. I don't know if it's because there's so many participants. Can you repeat the question?
Oh, sure, no problem. So I'm saying that in that ABS report, they identify a number of leaks, in the around 60, I think it is, that have been verified and that were based upon review of the Navy's documents. And my question to you is there any reason for you to doubt that the ABS conclusion that there have been a number of leaks that have occurred over the years?
So that report took from documents that stated there were leaks without confirming what leaks, if they were contained, if they were investigated, if they were removed, if they were from the telltale system, if they released into the environment, if it was a leaking valve or not. So yes, we have many documents that don't go into detail about releases in the system at Red Hill that were cited in that report.
So you do doubt that there have been a number of leaks over the years at Red Hill?
I believe that we do not have strong. Yes. Because we don't have complete data from those reports. They were literally secondhand differences. They weren't from 1970 onward, when we were required to report releases. Those are the ones that I trust and verify, that are verified if they released into the environment. Over.
So again, so your position is you think that ABS got it wrong. There's no real evidence to show that there's been a number of releases at Red Hill over the years.
Yes.
Okay. So then we're going to move on to the statutory or the regulatory requirements that apply to Red Hill. When did the regulatory requirements applying to this type of field constructed underground tanks go into effect?
For the HAR or for 40 CFR 280?
For the HAR, for what you're trying to get a permit now.
So the HAR, the 280, the deferral was removed in 2018 or 2019 when it was
In 2018 or 2019?
280.
I think she's
So-
frozen.
Yeah, I'm sorry, Ms. Smith. I
So-
think your transmission is frozen.
Ms. Smith, are you able to hear us at all? Okay, can somebody give her a call? She may not be aware. Wait,
Sorry, I'm back. I don't know.
okay, that's all right.
Yeah, there's about 4 inches of snow, and we lost our heating, and the internet's been out. So I apologize.
Okay, let's pick up from where we were. Ms. Gannon, you want to repeat your query?
Sure, thank you. And if you're having any trouble hearing me, I can certainly try to speak up, or I'm happy to repeat it. Just let me know if there's any problems understanding what I'm saying.
Okay.
But again, you said that the HAR, the regulatory requirements that are at issue in this case, when did they go into effect?
I think 2018 or 19.
And we had just talked about the corrosion protection standard, and I appreciate your correction about the difference between recognizing that B applies to the tanks and C applies to the pipes. And so I want to turn back to that section as well, and I'll pull it up for you. And I'm using it from the Navy's Exhibit 56. Can everybody see that?
Not yet.
Oh, I can share from this screen. How about now? Is it sharing?
Yes. So what section are you looking at?
It's showing you the wrong thing though. I seem to be sharing the wrong screen. Hold on a second. Is the regulation showing for you?
I see the regulation.
Oh, okay. Yeah, it's weird. I don't see on the screen. So, okay. So if this is looking at 11280 120-B, and I am fine for us just to use the 20B, 20.1B rather than having to say the whole regulations. I think that's easier. So as you recognize, this provision now it does apply to the Red Hill tank facilities. Is that correct?
Yes.
And so because these tanks are underground, they must be protected from corrosion. Is that correct?
Yes.
And there's a number of provisions here in ways that they could meet this requirement. And we just can run through them quickly under one, constructed of fiberglass. Does that apply at Red Hill?
No, number 3 applies.
Number 3 applies. So because they are constructed in steel and clad or jacketed in a non-corrodable material. Can you explain how we meet that requirement?
Yes. So this, the preamble in the EPA regulation actually goes into a little bit more detail and says any tank that is constructed of steel, but the non-corrodable material surrounds it, such as concrete, then that is considered meets corrosion and does not need cathodic protection. So the point is,
Where in the Hawaii regulations is that provision found?
No, it doesn't say that. I am taking that from the preamble from 40 CFR 280, since they were supposed to, the HAR is supposed to be stricter than the 40 CFR 280. And so only in the HAR, it says the tank is constructed of steel and clad or jacketed with a non-corrodable material. And I am referencing the 2 documents that I'm familiar with that go into more detail about that, since this mirrors the 40 CFR 280.20 with the tanks. It also says in that the tank is constructed of steel and clad or jacketed with a non-corrodable material.
Okay, but are you familiar with the section 2081-26C, which has the state definition for clad and jacketing?
Let's go to that.
I'm going to. Gotta highlight this. Okay, so this is the section, I'm sorry, it's not highlighted here, but it's this section. So this is the definition for how you can comply with these performance standards, right? That's what it says up here. And if we go down to section C, this says this is how you can comply with 20B3, which is the clad or jacketed section. So can you tell me which one of these sections 1, 2, 3, or 4 the Red Hill tanks comply with?
No, I am sorry, I cannot.
Okay. Okay. So then let's go on, and I'm also interested in your experience with other kind of using concrete as clad and jacketed for a UST systems. Are you aware of any UST system that is known to have corrosion occurring where they have relied on concrete as a clad or jacketing method?
Yes, the steel does corrode slightly, even if it's in concrete, but not at a rate to be of concern.
And usually with those also have some sort of cathodic protection on the steel?
No. Our field constructed tanks that are steel encased in concrete don't have the cathodic protection on it.
Oh, but then you said that they do experience corrosion.
They experience slight reduction of the steel, some steel loss.
As a result of corrosion. Is that correct?
Yes.
Okay. Okay, then I wanted to go next to section 2280.133, which you had referenced in your testimony saying that we could comply with these. And these are the provisions that apply when a tank has been repaired. Is that correct? I'll get there in a second, sorry. Right. So this is the section that I'm referencing, which is about repaired tanks. Do you see what I'm talking about?
Yes.
Okay, and then I want to go down to this subsection, and could you read the highlighted provision to me?
Yes, prior to the return to use of a repaired US system, any repaired US must pass a tank tightness test in accordance with section 11-280.1-43 3.
Okay, so then let's go to 280.1-43.3. And is it your position that Red Hill can meet this test? Yeah, I'll pull it up in a second, but I thought your testimony had been that you could meet this requirement. Was that correct?
Yes.
let me get to the provision, and I'd like to talk about how we know that. 43, I'm sorry, I'm so slow going through this. Now I can hear the leaf blower. I couldn't hear it before. So here it is, 280.1-43. I'll get down to the reference. And here it is. So this is the provision that you have to be able to comply with, and that you say that you can comply with. Can you just read this section to me?
Yes, tank tightness testing, or another test of equivalent performance must be capable of detecting a 0.1 gallon per hour leak rate from any portion of the tank that routinely contains product, while accounting for the effects of thermal expansion or contraction of the product vapor pockets, tank deformation, evaporation, or condensation in the location of the water table. So my understanding was that we because they're the field constructed tanks, they can adhere to 10, which is a tank tightness test of 0.5 gallon per hour leak rate. Over.
And where is that provision in the regulations found?
It's a little bit further. It's down at 10 for the field constructed tanks.
But
if you scroll down.
Okay.
So in this one, since it has methods of release detection for field constructed tanks.
This is for all the tanks, right? Not just for the repaired tanks. So when the earlier section cross-references said it has to comply with 1-43.3, I don't understand where it says that doesn't apply to field construction tanks. I read the regs as saying you have to be able to comply with 280.1-43.3, and we just read that language. Then we just looked at 43.3, and that talks about a 0.1 gallon per hour detection rate. Isn't that right?
Yes.
So you can't meet that standard.
We have not asked the test vendor to meet that standard, so I cannot confirm that.
So for example, when tank 5 was put back into service after being repaired, you didn't confirm that it met this standard. Is that correct?
We did the 10. We did the 0.5 gallon per hour leak rate.
Okay, so you didn't comply with this provision as it's stated in the regulation.
Yes.
And you testify you state in your testimony that the release response requirements found in state regulations apply to Red Hill. Is that correct?
Can you repeat that one more time?
You say that the release response requirements found in the HAR apply at Red Hill.
Yes. Sorry. Yes.
Okay. And there is a release requirement that you have to clean up any spill of more than 25 gallons. Are you aware of that provision?
Yes.
And can you explain to me how you do that? How do you clean up fuel that is spilled?
So for a tank, if it spills into the tunnel, we would use a spill pad to clean up the fuel. In the case of the Red Hill Tank 5 release, we negotiated with EPA and DOH and determined it would be better not to punch holes in the basalt rock to try to find the fuel. Over.
But so you have a plan that if it spills into the lower tank, you go in and you clean it up. What if there's another spill into the environment? What is your plan for how you clean that up?
That is not my department. Sorry.
Okay. Has the investigation and remediation of release report that you referenced in your testimony, has that been approved by the agency?
It is still pending. It's still in negotiations.
Okay, so it's not an approved document.
The section 6 or the section 7?
You can answer for both.
I think they're both pending review, actually.
Okay. And you state in your testimony that the DOH and the EPA agreed, and you just referenced this, that penetrating the rock in order to locate the fuel could create pathways for the groundwater. So it was exempted from this requirement. Can you point us to the document that provides that approval?
Well, it was the administrative order of consent and the statement of work combined was the way forward. I'm not sure if we had it in writing from the state besides verbal when we just went into negotiations with them once we submitted the release.
Okay, so your thought is that was just a verbal conversation, and that was the basis for not having to meet this regulatory requirement.
I can't be for certain. I'd have to ask NAFAC Hawaii that.
Okay. And you talked about in your testimony that the tank tightness equipment is maintained by an outside contractor. Can you explain to me what kind of oversight the Navy has over that contractor?
So that contractor is contracted out through NAFAC LANT, it's a centrally managed program funded by Defense Logistics Agency. And so the KO in NAFAC LANT has oversight over that contractor.
And do you know what kind of quality assurances, QA/QC they do on the contractor's work?
I would have to ask the KO.
And are you aware of any place in the record for this proceeding where that information can be found?
I do not think so.
Can you define the KO?
Sorry, the contracting officer of the contract.
Okay, thank you.
Okay, and turning now to the tanks closures that have been done. So tanks 1 and 19 have been permanently closed. Is that correct?
Yes.
And do you know what the basis for that closure was?
So we hadn't used them and we gas freed and inerted them for tanks 1 and 19.
Okay.
Yes.
And you indicate that the normal procedure under the state regulation for a closed tank is that they would either be removed or filled with a solid inert material. Is that correct?
Yes.
And has that been done?
No, so NAFAC Hawaii worked with the DOH hearing officer, Richard Takaba, and determined that it would be impractical to either remove the 2 tanks because they're so large. The tank system, because the other 18 tanks were still in service, the structural integrity of all of those tanks were indeterminate, so they decided we didn't have to remove it. And then filling a 12 million gallon tank with inert material, they also decided was costly. So they agreed to just keep it gas freed and provide the notification, which NAFAC Hawaii did.
And again, can you point me to the written approval of this approach that was provided by the Department of Health?
I do not have that. I don't, NAFAC Hawaii has that. Raylan Kashaba, the tank program manager for Hawaii, has that.
And do you know if that's in the record?
I do not know.
I'm not aware. I have not seen that. And then there was a reference in your testimony that you submitted this closure plan in 2007, January of 2007 for 109 to DOH. Did DOH approve that closure plan? Was there a formal approval received?
I'm not sure if it was formal, but an email was received that said that they accepted the closure notification.
Okay. All right, I think that's all I had. I thank you for walking through this with me.
Thank you.
Can you give me 2 minutes? Can't hear you.
Hearing Officer Chang, you're on mute.
Yeah, thank you. Sorry. Yes, no problem. We'll take a very short break.
Thank you. All right.
Okay, back on the record.
Ms. Smith, you don't live on Oahu, do you?
I do not.
Okay. And are you familiar with the requirements of Hawaii's public trust doctrine?
Sorry, I was on mute. No.
So you don't know if granting the permit would be consistent with Hawaii's public trust doctrine?
No.
Okay. You are aware, however, that Hawaii's underground storage tank law is stricter than federal law.
Yes.
Okay. Are you familiar with the fact that the Red Hill tanks leaked in 1948, 49?
I'm aware that we have documentation that states that, yes.
How about, are you aware of the leak in 1958 of 1,500 gallons of fuel?
I don't have that. I haven't reviewed the release documentation in a while.
Okay. Are you aware of the 1971 release from Tank 1 that leaked more than 20,000 gallons of fuel?
I don't recall that, but it could.
Okay. How about the 1980 a leak from Tank 11 of 25,628 gallons of fuel? Is that something you're familiar with?
No.
Okay.
I didn't review
Are
this
you familiar?
data before this call.
Okay. Are you familiar with that in 2002, the Navy confirmed the release of fuel of unknown quantities?
No.
Okay. So if you knew all that, that might alter your answer about whether you thought there'd been a history of lots of spills or not, right?
Since I don't know the document sources for those, yes, I cannot confirm.
Okay. Have you seen or heard any, read anything about the sum total of the amount of fuel that's leaked since they were installed? A calculation that amounts to more than 178,000 gallons of fuel?
Yes, I'm aware of that.
Do you have any reason to dispute it?
I cannot.
Okay. So I want to go through some of the rules that we just talked about. See if we can. I'm gonna try to bring up the sections of the rules. See if I understood you correctly. So we have some sections of the, going to go first through, make sure I understand. So this is a part of HAR 11-280.1-20. And I believe that's exhibit N-56. The Navy has provided the rules, a convenient copy of the rules. So you said that section B of this, subsection B of this section, which requires that the tanks be protected from corrosion. You said that the Red Hill tanks fulfill subsection 3. The tank is constructed of steel and clad or jacketed with a non-corrodable material, right? That's the provision.
Yes.
And when we go down to 280.1-26, paragraph C, and it says the following codes of practice may be used to comply with section 11-280.1-20B3, the section we just referred to. You said you do not know which of these 4 categories the Navy's tanks comply with, correct?
Yes. I would also add that it says may be used, so they may not have to be required. So if it's with the concrete, it may not be in this 1 through 4.
Is there any other code of practice out there that you know of that would or has accepted concrete cladding as a safe method of protecting tanks from corrosion? Are there any codes of practices like that?
I am not sure.
Okay.
I did not research that, since in the preamble and discussing it with EPA, they confirmed that concrete's a non-corrodable material. So I did not do further investigation.
Okay, and okay, I'll leave it at that. Okay, let's go to the next section that was interesting. We talked about 11-280.1-43 about tank tightness. Actually, I'll go down here first. Sorry, -33 first. So you read this section. It requires that prior to the return of use of a repaired underground storage tank system, any repaired underground storage tanks must pass a tank tightness test in accordance with section 43, parent 3, right?
Yes.
And if we look at section 43-3, it requires tank testing capable of detecting a 1/10 of a gallon per hour leak rate from any portion of the tank, right?
Yes.
And you're not aware of any Navy test that has fulfilled this requirement?
No.
And no means you're not aware, correct?
No, I'm not aware.
Okay.
I do not. Yeah.
Okay. Okay, let me stop sharing and let's talk about the alternative of relocating the fuel that's in the underground storage tanks. So the Navy replaced the tanks at Point Loma, correct?
Yes.
That's in San Diego?
Yes.
Those tanks had leaked.
Yes.
And new tanks were built above ground.
Yes.
The Navy also replaced the tanks at Naval Base Kitsap.
No. There's currently a mill proposal.
So they're replacing, they're in the process of replacing them.
Some of them.
And that's in Washington State.
Yes.
And those tanks face seismic risks.
Yes, the ones they are replacing are on a fault line.
And the new tanks are being built above ground.
Yes, away from the fault line.
No further questions.
All right. Mr. Page, any questions?
No questions.
Okay, any redirect?
We'd like to request a short break before redirect.
Okay, how much time would you like?
10 minutes, please.
Okay, let's take a 10-minute recess.
Thank you.
Sorry, I think I'm back online.
No problem.
You are, but you don't need to be. You can stop your video if you want.
Can you please repeat the last question?
Wait.
Hello?
I mean, I think everybody's gone.
Yeah,
Or
we're in
off
recess, so let's wait until everybody reconvenes.
Oh, okay, sorry.
We have
No
10
problem.
minutes.
Yeah.
Okay, thanks.
please. Make sure.
Okay. Appears everyone is back. Ready? Are we ready to resume, Ms. Riddle?
Yes, we do not have any redirect at this time, but would you like to ask Ms. Smith any questions?
I have a couple areas. Ms. Smith, I think I understand your statement, but I want to confirm and be clear about it. Is this current pending application for a permit for the Red Hill facility the first time that the Navy has been required to apply for such permit?
Yes, that is my understanding.
And is it because of the history of the regulations coming into effect in what, 2018?
Yes, with the field constructed tanks no longer being deferred, we now, and the airport hydrant system and the tanks all being together as one system, yes.
Okay, I have a question for counsels for the Navy. The Navy had earlier indicated that one of the issues in the case was whether or not the Navy was even subject to the regulations. Is that no longer an issue?
That is something that we would like to reserve our rights on.
Okay, I have that noted as an issue, so we will hear more then when you're ready to add more to that. And I wanted to ask Ms. Smith if you could explain a little further the statement in your testimony. You were referring on pages 4 and 5 of your testimony to applications for approval that is pending. Can you kind of explain that generally to me?
For that we're still, that DOH gave us continued operations while the permit application is pending. I'm sorry, I don't remember 4 and 5.
Okay, I'll read the section on page 5 of your testimony. State of Hawaii has updated its UST regulations to incorporate the revised 2015 federal requirements. The state has applied for formal approval of its revised regulations, but they have not yet been approved per the EPA's state UST programs page, and you reference an exhibit N57. I'm not understanding the totality of that.
Okay, so 40 CFR 280 is the federal regulations, and then 40 CFR 281 allows for states to submit to the EPA to be considered the regulator on behalf of the federal government for the underground storage tank systems. So they have to submit their revised regulations that mirror or are more stringent than the 40 CFR 280 that was promulgated in 2015.
Would it be reasonable to expect that those Hawaii proposed regulations would be approved by EPA because they are stricter than federal regulations?
Yes, I presume they will be, but I do not want to speak on behalf of the House office.
Certainly. Now, you were asked some questions, and I'm a little unclear about the context. We were talking about release requirements for quantities of spills. And then there was some testimony about the matter is in negotiations and is pending with the EPA and DOH. Is that a different topic from what we just talked about, this federal regs and Hawaii regs?
Two separate things. So pages 4 and 5 are specifically DOH getting approval from EPA for the HAR. The other one with the spill, so the January 2014 fuel spill, those we entered negotiations with EPA and DOH to do an administrative order of consent. Instead of meeting the previous HAR requirements for finding the fuel, we came up with a administrative order of consent to meet the investigation piece of it. And so sections in the statement of work, sections 6 and 7 are specifically to meet the reporting, or to not, instead of finding the fuel. No.
And so generally then you're saying the AOC is the alternate process that has been agreed upon between the EPA, Department of Health, and the Navy as to what needs to be done because of the 2014 release.
Yes. To
All
meet
right.
subchapters 5 and 6.
To meet what?
To meet the subchapters 5 and 6 of the HAR.
Okay, and because I'm not completely familiar with that, what are 5 and 6 deal with?
So those are the finding the fuel, cleaning up the fuel, protecting the environment, and then investigating to make sure it's all cleaned up. And reporting.
Okay. All right, I have no other questions. Does anyone else have any follow-up questions? Hearing none, are we done then with Ms. Smith?
We are. Thank you.
Yep.
All right, thank you very much, Ms. Smith.
Thank you.
Hey, take care. Okay, Navy's next witness? Or do we want a break? It's been about an hour.
We could probably appreciate a break to get our witness up and running. 15 minutes?
All right, we will resume in 15 minutes. Are we ready to resume?
Yes, the Navy is.
Okay, Navy is calling Mr. John Floyd.
Yes, we are.
Okay.
We should be coming on right now.
Okay.
One moment. We're
Good afternoon, John Floyd here.
Welcome, Mr. Floyd. Okay, we are ready to go back on the record. Mr. Floyd, at this time, may I ask you to take your oath and then the questionings will begin.
Yes, sir.
Please raise your right hand. Do you solemnly swear or affirm that the testimony you're about to give be the truth, the whole truth, and nothing but the truth?
I do.
Thank you.
All right. Ms. Minot, are you conducting the exam?
yes, I will be.
Okay.
So Mr. Floyd is currently the Deputy Director here at the Regional Fuel Department for Naval Supply System Command for the Fleet Logistics Center, Pearl Harbor. Mr. Floyd here, he manages all aspects of fuel operations to include fuel receipt, storage, delivery, quality surveillance, and inventory management. Mr. Floyd, are there any corrections that you would like to make to your direct or supplemental testimony?
Yes, I would like to make one correction. I'm not sure what question it was, but I believe it was related to the term. There is a passage, a sentence in there that states that we are double walling the nozzle piping. That is not correct. That is a proposed TUA implementation plan, tank upgrade alternative, but we're not there yet. Thank you.
Thank you. We now offer Mr. Floyd for cross-examination.
All right. Mr. Brown, are you?
You have David Brown here. Can you guys hear me okay?
Yes.
All right, perfect. I will be conducting the examination for the Board of Water Supply.
I'm sorry, I can't hear you. I would like a headset, please.
Okay, let's go off record for a moment. Let's take care of that.
Headset's coming in.
Okay.
Want to do a test?
Mic check.
I can hear you. Good afternoon, Mr. Floyd. Can you hear me?
Yes, I can.
Okay, let's go on the record then, Mr. Brown.
Okay, good afternoon, and thank you for joining us, Mr. Floyd. My name is David Brown, and I represent the Board of Water Supply. I have some questions for you today about the written testimony you submitted in this matter. I just want to make sure before I start, you got your headset on okay and you can hear me?
Yes, I do.
All right, if you have any problems with that, let me know. We can take a break.
Okay.
So Mr. Floyd, you testified that you ensure completion of all required maintenance and repair work at the Red Hill facility, including preventative and corrective breakdown and outsourced contractor maintenance. Is that correct?
That's correct.
So are you familiar with the repair work performed at Red Hill to address the Tank 5 fuel release that was reported in January 2014?
That occurred before my tour started, but however, I am familiar with it. I've read the records and I have been managing the facility and responsible for making corrections since then. Yes.
Okay. Can you tell me what was done immediately after the Tank 5 fuel release in the next several months with respect to that tank?
So immediately, the tank was drained down and drained empty. The next step was that the current contractor, Real Bros, came in and they completed warranty work. We had a second, third party come in. They proved up some of the Real Bros repairs. After Real Bros completed all of their warranty work, that means NAVSUP, NAVFAC, and DLA in Navy Region Hawaii, we did not feel comfortable putting the tank back in service at that time, and we ordered another complete inspection of the tank.
And why weren't you comfortable putting it back in service at that time?
Well, Real Bros had initially failed us. There were a lot of problems with the craftsmanship of their work, the QA, the QC process, and because of everything that was at stake, leadership decided that we'd be better off completing another complete inspection of the tank.
And was there ever a search for the source of the leak?
I'm sorry, sir, I don't understand your question.
Sure. Was there ever a search for the number of different points within that tank where fuel was released with respect to the tank 5 release that was reported in January 2014?
So would not call it a search. However, when we went back and we did QA or trued up the repairs made, we found a number of faulty repairs that most likely contributed to the source of the leak.
Does the Navy know from how many different places in tank number 5 the fuel was released between December and January 2014? December of 2013 and January of 2014, apologies.
I am certain there's someone that is in the repair organization, most likely EXWC, Expeditionary Warfare Command, that are responsible, or the actual POL SMEs responsible for the tank repairs. They may have that information. I do not have that information. I've heard that it could be, I think, maybe 16. However, I'm not sure.
Okay. Do you know which document would record exactly how many different places in tank 5 that the fuel release occurred from?
No, I don't.
Do you know if that document would even have been in the record for this proceeding?
If it was memorialized in a document, that would certainly be the post-inspection report that documented everything that was found and all of the repairs made.
Okay. You had mentioned Wilbros. I'd like to bring a document up for you, so if you can give me 1 second while I share my screen. Okay. Let me know, Mr. Floyd, if you can see my screen.
Yes, I can see your screen.
Okay. So can you see this document? Let me make it a little bit smaller for you. I don't want to make it too small. This is Navy exhibit number 7 with a bait stamp here, Navy 0000517. Do you know what this document is?
No, I don't. Could you continue to scroll down?
Sure. It's this document's on Navy letterhead, correct?
Yes, it is.
And it's addressed to Wilbros Government Services?
Yes.
Is that the same tank contractor that you were speaking about earlier?
Yes.
And this says for the subject line contract number N62583. I'll omit the rest of the number there, but it says clean, inspect, repair tanks 5 and 17, Red Hill, Pearl Harbor, Hawaii. Is that right?
Yes.
Can you take a look at the first 3 bullets underneath the language right here by my cursor? It says preliminary investigation has provided the following information. Can you read those first 3 bullets for me, please?
Yes, the operators of the tank reported a loss of product during the initial filling operations, and the gauging logs show a loss of product over the 30-day period. Bullet 1. Bullet 2, there was a reappearance of fuel on the lower tunnel wall after the tank was refueled. Bullet 3, the monitoring well nearest to tank 5 has shown a significant spike in petroleum products.
Do you agree with those statements, Mr. Floyd?
Yes.
So do you know what was meant by a reappearance of fuel on the lower tunnel after the tank was refilled?
No, I don't.
Is it possible that tank 5 had released before in the past and that there was fuel on the wall in the lower access tunnel?
I have no knowledge of that occurrence.
And do you have any reason to believe that the monitoring well nearest to tank 5 didn't show a spike in petroleum products at that time?
My recollection of the monitoring logs for monitoring well number 2 is that it did show a spike after the fill of tank 5.
Okay, thank you. Do you know who wrote this letter?
No, I
The
don't.
information is redacted.
No, I don't.
Okay. Thank you, Mr. Floyd. The Navy identified some lessons learned from the fuel released from tank 5. Is that correct?
That's correct.
And Commander Whittle earlier today testified that the Navy performed a root cause analysis, or RCA, to identify those lessons. Are you familiar with that root cause analysis?
No, I'm not.
Okay. Why wouldn't the Navy perform a root cause analysis to determine why the tank 5 release happened?
I can't answer that without speculating.
Okay. Let's change gears real quick. I'd like to ask you a few questions about your testimony concerning layers of protection. So you indicated that there are 3 layers of protection related to releases that are implemented at Red Hill, and those are prevention, detection, and mitigation. Is that right?
That's correct.
And in your written testimony, you spend about 20 pages discussing these different methods that are implemented at Red Hill. Does that sound about right to you?
Yes.
You only devote a page and a half of your testimony to prevention and 1 sentence to mitigation. The other 18 pages discuss the detection of releases. Why is there so much more focus on detection of releases rather than prevention and mitigation?
So prevention is fairly straightforward. How do we prevent it? With our enhanced maintenance procedures, with our overfill protection system, and our operational procedures. So that's pretty straightforward, black and white. Detection, there's a bit more involved with detection, as we discuss, walk through the system of systems. So certainly prevention is the most important aspect, right? We want to keep it in the tanks. But when you look at my testimony, you read my testimony, you see how we operate the facilities, that's pretty straightforward. The detection just simply required a bit more explanation.
Okay, that's fair. Mr. Floyd, you testified that prevention of releases is accomplished through the tank inspection, repair, and maintenance, or TIRM process. The Navy relies upon that TIRM, or I can call it term process, to prevent fuel releases. Is that correct?
We rely upon the term process to ensure the hydraulic integrity of the tank to prevent fuel releases.
So the hydraulic integrity of the tank is necessary to prevent fuel releases.
Certainly important to that, yes.
Are you aware of the destructive testing that was performed by the Navy on Tank 14 in June of 2018?
Yes, I was on the periphery of that. I'm aware that we took 10 coupons out of Tank 14 to validate our non-destructive inspection methods.
And did you view those steel liner samples that were removed from Tank 14?
Yes, I did.
Okay, I'd like to bring up another exhibit to show you. Bear with me as I work this technology. Okay. Can you see my screen all right?
Yes,
Mr.
I can.
Floyd?
Yes.
Okay. This is Navy Exhibit 32, the IMR test lab report on destructive analysis of the 10 steel coupons removed from the Red Hill storage tank number 14. Are you familiar with this document, Mr. Floyd?
Somewhat, yes.
Somewhat. I'd like you to take a look at a few of the pages of this document and ask you some questions about that. So what I have on the screen, and tell me if you need me to blow it up a little bit more, is figure 1 from the IMR test labs report. Do you know what this is an image of?
That is one of the coupons that was removed from Tank 14. I think we're looking at the backside of it.
Correct. It's the backside of coupon 1. What is your understanding of the brown substance on the backside of this steel liner sample?
I don't know what it is. So one, I like to qualify myself. I'm not a metallurgist or a material specialist. We brought in another Navy organization to manage this process. That's Navy Expeditionary Warfare Command. And their corrosion experts or their NACE experts are the ones that manage this project. So my area, again, my area of expertise is in the operations and maintenance of the facility. I did not delve deep into this process because we have specialists that do this for us.
Certainly, but to be able to understand, how to maintain this asset, these tanks, wouldn't it be important for purposes of your role at the facility to understand the types of threats to tank integrity?
Yes.
And so wouldn't understanding, and I think you mentioned the term corrosion, be important for purposes of maintaining, repairing, and ensuring the integrity of the Red Hill tanks?
Yes.
So wouldn't it be something you would be interested in to understand what was coming off of the backside of these coupons?
Yes.
So do you have any reason to believe that what we're looking at here is not corrosion?
No.
And excuse me, Mr. Brown, I'm sorry to interrupt you, but the image says it's the interior surface. Can we clarify that?
Sure. This one right here, and actually it's I think that this may just be a typo on this document.
Okay.
Because these are certainly, and I can pull it up in a different document.
They have it reversed then, right?
Yeah.
Okay, I understand.
And let me pull up a different document then. Hold on. There we go. This one is a little bit smaller, but I can blow it up for you. So this is Navy Exhibit 27. It is the field sample notes taken from the coupon sampling from tank 14. As you can see, Mr. Floyd, the date of this, at least coupon number 1, says Wednesday, June 20th of 2018. So that's consistent with your understanding of when the coupons were removed from tank 14?
Yes.
Okay. And then there's quite a bit of information in here on the specifics of the coupon and the visual examination. There's a drawing here, and I'll go down, and this is the same coupon that we just looked at. And actually, let me scroll up for you. And this one actually makes it clear that this is the exterior on the left and the interior on the right. And we can see that the other document was simply inverse. So let me make this a little bit bigger for everyone. Same document or same photos. So back to my initial question. Do you have any reason to believe that this is not corrosion that's afflicting the exterior of Red Hill tank number 14 at coupon number 1?
No.
Okay. And if we scroll down, this is coupon number 2. Do you have any reason to believe that the brown substances on this coupon are not corrosion afflicting the exterior from the backside of coupon number 14?
No.
Sorry, coupon 2 number tank number 14. And now we have coupon number 3. This one, the image is not as good, but there is a identification here. And let me scroll out for you a little bit. Does it indicate that for coupon 3, there's the presence of corrosion?
Yes.
How about for coupon number 4 that we're looking at right now?
Yes.
This is coupon number 5. I apologize for scrolling to, or actually 6. Apologies for scrolling too fast. Does the document indicate there's presence of corrosion?
Yes, small.
And this is coupon number 7. Does it indicate there's the presence of corrosion?
Yes.
We have an image of coupon number 8 here. Apologies for the scrolling. Same question. Do we have presence of corrosion?
Yes.
And then coupon number 10. Presence of corrosion?
Yes, small.
This is coupon A1, which I understand stands for the alternate coupon selection number 1. That was actually removed. Was there presence of corrosion on this coupon?
Yes.
And finally, coupon number A2. Was there presence of corrosion?
Yes, general.
Thank you, Mr. Floyd. So we just walked through the 10 coupon samples. Every single one indicated the presence of corrosion. Is that correct?
That's correct.
Were you surprised by the amount of corrosion present on the backside of the steel liner samples?
No, I was not. The coupon study was done in accordance with Section 5 of the AOC. And the purpose of that study was to validate the inspection procedures that had already documented indications that were on the backside. So this basically validated what our inspection procedures, what our inspection had already discovered.
And Mr. Floyd, weren't the coupon selections chosen to represent areas where there would be no corrosion as well?
I'm not sure of that. I can't answer that. Sorry.
These steel liner samples were sent to a Navy laboratory and underwent laboratory testing and measurements, correct?
Not sure if it was a Navy laboratory, but it was certainly sent to a laboratory for analysis.
And what were the results of that analysis?
I'm not familiar with that.
Okay. Do you know if the Navy submitted a report on the destructive testing results?
Yes, I believe so.
And what was your understanding of what that report said?
So I cannot recall the report simply because that is something more in the repair arena with NAVFAC, specifically NAVFAC XWIC. So those, that's the organization, that's the that was responsible for that section of the AOC that was responsible, had the lead on this project. So no, I'm not familiar with that report.
Mm-hmm. Let's take a look at what the Department of Health and the US EPA said about that report. Excuse me, I'll share my screen. Okay, can you see my screen, Mr. Floyd?
Yes.
This is a letter from US EPA and the State of Hawaii Department of Health dated July 7, 2020, addressed to Captain Mark DeLeo, regarding the agency, a response to the Navy letter acknowledging the agency disapproval of the Navy's corrosion and metal fatigue practices destructive testing results report. And in this letter, US EPA and the Department of Health provide several statements, but I like to direct you to this statement, the first full paragraph where my pointer is going, and it says the regulatory agencies do not concur that the Navy and DLA's destructive testing efforts have demonstrated that the Navy's practices are sound. It goes on to say that there will be work performed under the AOC in section 5.4. What's your understanding of AOC section 5.4?
I'm not familiar with that section of the AOC.
Okay. Let's pull that up. Okay, can you see my screen, Mr. Floyd?
Yes.
Okay, so this is the administrative order on consent statement of work, which is attachment A there to exhibit B82. And let's go down to the section 5.4. So decision or section 5.4 states, if the parties determine that the results of the previous deliverables in this section indicate the need for evaluation and implementation of potential changes in practices to control corrosion or metal fatigue, the Navy and DLA shall, within 60 days from the regulatory agency's approval of the destructive testing results report, schedule and host a scoping meeting to be attended by the parties for the purpose of developing appropriate modifications to the scopes of work and timelines in section 2 and or section 3. Are you familiar with section 2 of the AOC, Mr. Floyd?
Yes, section 2 is the term, tank inspection, repair, maintenance.
So we just reviewed a letter from the Department of Health and US EPA that stated section 5.4 for the AOC is supposed to be implemented. And section 5.4, which we just read, states that it is prepared for developing appropriate modifications for tank inspection, repair, and maintenance. What is the current status of the Navy's TIRM process?
Current status? No, I don't know. That is a question that's probably better asked to our Red Hill program manager. I think he's going to be on sometime during this process. He is the one that tracks the deliverables. The term, to the best of my knowledge, I believe is a complete report. And we have already began to implement the improvements from the term.
So this document, or this section of the AOC, which we just discussed, is being implemented in order to prepare appropriate modifications to the tank inspection, repair, and maintenance process is ongoing. But as the individual responsible for ensuring the completion of all required maintenance and repair work, you're not certain where term stands right now.
No, I'm not.
Okay.
So my understanding is that it's complete. However, we are continuing and we will continue to make improvements when and wherever we can to our tank inspection, repair, and maintenance procedures. So you're asking me something now about the destructive testing. As I stated, I am not an expert in this field. This is a section of the AOC that is managed by another organization. So where do I fall in relation to this? At the end of a tank CIR, I will get from the tank repair and NAVFAC, what is called a suitability for service. And that is what I look for. So I do not manage every aspect of the AOC. That's simply not my job. There are some items I'm more familiar than others, certainly term. I'm involved with TUA. I'm involved with leak detection. You get down to section 6 and 7, the environmental remediation, freight and transport. I'm not involved with that to a great extent, other than knowing that that is something that's happening in the background.
So let's move on to something that you did testify about specifically, and that's the decommissioning of nozzles. What are the small nozzles that are being decommissioned?
So these are the smaller pipes that we cannot put a human into in order to inspect it or to coat it or to make repairs. So to buy down risk, we are decommissioning the smaller nozzles or the smaller pipes leading into the tanks. We remanifold the piping outside of the tanks. So now we can direct 1, 2, 3 different products through one larger line, again, that can be internally inspected, repaired, and coated.
Okay. And has the Navy decommissioned all the Red Hill tanks nozzles, the small nozzles that are too small for humans to inspect?
No, we have not. Currently, we've only done one, that is tank 5. The nozzle modifications are part of the CIR, or the clean, inspect, repair process. So as each tank goes through the clean, inspect, repair process, that modification will take place.
How long does the Navy anticipate that it will take to decommission all the small nozzles on the Red Hill tanks?
Currently, our clean, inspect, repair process for the current cycle of tanks runs out to 2032.
And so just so that I'm clear, and I want to make sure I understand that, when you say the current cycle, in 2032, you will have clean, inspected, and repaired all the tanks and decommissioned all the small nozzles?
All of the 18 active tanks. (2032) is the start of the project for the last 2 tanks.
And when will that be completed?
Typically take about 3 years. However, we're as we complete more tanks, we've been able to develop better processes, better synergies, and we have been able to move the completion dates back, or what's the word, or increase the velocity in which we can complete the repairs.
So the 2035 date that you just mentioned is more of an aspirational date, right? That's not based on the current or historical pattern or time that it's taken for tanks to go through clean, inspect, repair, correct?
No, I didn't say 2035.
What did you say?
2032.
I thought you said that's when it would start and that it would end.
That's when it start. Yes, that's when it will start. 2032. We hope that we can get it done within 3 years, maybe less. I don't know.
But that's not the timing that it's historically been done in, correct? Most tanks have taken a lot longer to be cleaned, inspected.
Yes.
Okay. I had a couple of questions about some testimony you had concerning an inspection at Red Hill that took place in 2016. I believe is also referenced in the Navy's opening statement. That testimony states that an inspection date from inspection report to US EPA dated in June of 2017 indicated that the Red Hill facility met then current requirements. Is that correct?
Yes, I believe it stated that we met or exceeded industry standards.
And the current regulations, state regulations that the tanks operate under were not applicable until July 15, 2018. Is that right?
That's correct.
So that inspection report was issued before those regulations applied to the Red Hill tanks, right?
Correct.
So it doesn't state in that document anywhere that the Red Hill facility or the Red Hill tanks meet current state law requirements, does it?
So it met the overarching requirement, which I believe is 40 CFR part 112. And I believe that is what the state law was written from. I think the terms used at the state law can adopt 40 CFR part 112 or make it more stringent.
Right. And if it's more stringent, then that may mean more than what federal law requires, correct?
That's correct.
Okay. Mr. Floyd, you also make a statement in your testimony in which you attribute to Powers Engineering Inspection, or PEI, a statement about the likelihood of fuel staying between the steel liner and the concrete shell. But you're careful in your testimony not to attribute that comment to the Navy. We heard earlier from Commander Whittle that concrete is not a containment mechanism and that fuel gets into the subsurface. We also heard from you earlier today that you had no reason to believe that there wasn't a spike in the groundwater monitoring level, groundwater monitoring well after the tank 5 release. It's not your position personally or the Navy's position that all fuel that leaks through the Red Hill tank steel liner would stay between the concrete outer shell, is it?
I'm sorry, could you ask that question again?
Sure. Do you think that all of the fuel that's released from the Red Hill tank steel liners is going to stay within the concrete?
I have no idea. I stated what the report stated. That was a specialist that was hired by the EPA to come out and assess the facility. He's a very reputable tank inspector. So I accept what he states.
Was there a project to try to locate the fuel at Red Hill after the tank 5 release in between the steel liner and the concrete?
I'm not aware of such a project.
You're not aware of such a project? So you
No.
don't know if there was any at all behind the steel
No,
liner?
I don't. Other than what is currently being worked under Section 6 and 7 of the AOC. And as I stated earlier, that is being worked by our environmental engineers and geologists. And I'm not very familiar with their body of work.
Okay. I'd like to take a look at another exhibit. Okay. Sorry about that. Start at the beginning. Can you see my screen, Mr.
Yes.
Floyd?
Yes.
Okay. This is the Naval Audit Service audit report for the Red Hill facility from 2010. Are you familiar with this report?
I've reviewed it, yes.
Are you familiar with the findings and recommendations?
Some of them, yes.
And this is a report prepared by the Navy or on its behalf by some department of the Navy or the Department of Defense. Is that correct?
Yes.
Do you have any reason to believe that the conclusions in this report are not true?
No.
And it says in here that groundwater contamination exists around the underground storage tanks at Red Hill, RH, because of irregular maintenance and insufficient inspection over the life of the fuel tanks. For example, 6 of the 18 active Red Hill tanks have had no recorded inspection or maintenance efforts for 27 to as much as 46 years. Additionally, we determined that the inspection and maintenance schedule in place at the time of our site visits was infeasible because fuel requirements and time constraints limited the rate at which the work could be performed. Is this statement at all consistent with a conclusion that the Red Hill tanks can somehow withhold fuel and be fuel tight and not release into the environment?
I'm sorry, could you repeat that question again, please?
Sure. If there's a release outside of the steel liner, has it gotten into the environment before?
So we have had spikes in our soil vapor monitoring. We just discussed monitoring well 2 just outside of tank 5, all right, that had a spike, all right, indicating a release to the environment. Our groundwater protection plan, groundwater monitoring, I believe has detected constituents of fuel in the past. Not sure if there's been any detection of free floating product. That is a question best directed to our environmental specialists.
Okay. Thank you, Mr. Floyd. I'd like you to take a look at one more exhibit. And Mr. Floyd, you've been in the Red Hill facility, right?
Yes, I have.
Yeah. And you've toured the entire facility, right?
Yes.
That includes the lower access tunnel?
Yes.
And the lower access tunnel provides a pathway to travel to and from the tanks below the tanks, right?
Yes.
And when was the last time you were in the lower access tunnel?
Friday.
Right. Branching off the lower access tunnel are access points beneath each one of the tanks, correct?
Yes.
And at those access points, there are pipes for each tank that are used to distribute fuel through the facility.
Yes.
And those are where the nozzles are located.
So the nozzles are at the base of each tank, actually at the concrete plug of each tank. So the nozzles, that is considered the piping upstream of the last valve, isolation valve, and the piping as it penetrates the tank.
So sorry, just so that I'm clear, the nozzles are in the area underneath each tank where those where the piping comes off from the tanks, right?
Yes.
Okay. I'd like to show you exhibit B7. Can you see my screen?
Yes.
Okay, this is a newspaper article from the Star Advertiser dated June 22nd, 2014. And there's an image here. Are you familiar with this image?
Oh my. Yeah, it's the plug at the bottom of a Red Hill tank showing the skin valves. I cannot tell you what tank it is.
Sure. I'll read the caption for you. It says, a close-up of the wet spot in the concrete below tank 5 at the Red Hill underground fuel storage facility. The wet material matched the jet fuel that was emptied from tank 5. Do you have any reason to believe that this is not a photo taken in 2014 in the vicinity of tank 5 that shows fuel seeping through into the lower access tunnel?
No reason to believe it's not.
And you were in the lower access tunnel last Friday, right?
Yes.
When you went to the lower access tunnel, did you come by the area where tank 5 is located, where this point is?
Yes.
And isn't there still visible staining there beneath tank 5?
Yes.
So how is it in your testimony then that you state there was an inspection in 2020 and that no fuel leaks or visible staining was found in any of the operational Red Hill storage tanks, surge tanks, above ground tanks, Hickam tanks, hydrants, or any pipelines?
So to be clear, there were no fuel leaks discovered during that inspection. That is a stain. If it was stained in 2014, you can reasonably expect it to be still stained in 2020, 2021. So we did not go back and repaint that area.
So it is not a correct statement to say there is no visible staining of fuel around any of the operational Red Hill storage tanks.
So the correct statement is that there was no evidence of any fuel leaks during active fuel leaks during the 2020 Department of Health inspection.
But there is staining and there is visible staining, and it's still
Yes.
Thank
Yes, so that staining from tank 5 has been previously reported, very well documented. It's in the Star Advertiser. It shows up on TV news. That is something that we do not refute at all.
Okay. I appreciate your time, Mr.
thank
Floyd.
you.
I have no further questions.
Thank you, sir.
So, Mr. Frankel, are you next?
Yes. Deputy Director Floyd, you were just asked about that photo, and I was curious, how much concrete would that fuel have had to have traveled through to stain that wall?
I believe the tank sits on a 20-foot reinforced concrete plug.
So that fuel that stained the wall traveled through 20 feet of concrete to get there.
Yeah, I would surmise that, yes.
Okay, thank you. Now, on page 14 of your testimony, you talk about necessary steps to prevent releases. I want to talk about 3 of those steps that you talk about in your testimony. And if any of these are not your area, if there's another witness who should talk about it, let me know, and we'll ask questions of him or her. The first one step you talk about is recoating the tank interior. You know what I'm talking about?
Yes.
And that's to prevent corrosion, to help prevent corrosion, correct?
Yes.
And it's an important protective measure.
Yes.
How many of the 18 tanks have been recoated with the polysulfide?
To be clear, under the current term, we recoat the lower dome and the extension ring and certain repairs that were made to the tanks. Right?
So that doesn't include the barrel then?
No, it does not.
Okay, and how many of the upper part of the tanks have been recoated with the polysulfide as of today?
So tank 5, we coated the lower dome and certain patch plate repairs. Tank 5, of course, that contract was awarded before our term. Under the current concept of repair, we're again coating that lower dome, I believe, 50 to 55 feet, first 50 to 55 feet of the tank, and the extension ring.
Okay, so are you telling me that tank 5 is the only one that this important protective measure has been implemented on so far?
Tank 5, we did not coat the extension ring. The tanks that are currently undergoing repairs under the new term will receive those repairs.
And so that means there are 14 tanks currently in operation that have not been recoated with the polysulfide. Is that right?
So to be clear, we do not do the coatings until we take the tanks down for clean, inspect, and repair. So the tanks that are currently undergoing the clean, inspect, repair, they will receive this new coating, this new addition to how we repair tanks. So the tanks that are in service, right, you are correct. Those tanks have not undergone their maintenance cycle yet. So you're correct. We have not done that.
Okay, so there are 14 tanks that are operating that have not been recoated, right?
So the term recoating, again, we recoat the lower dome, and the new process is that we're coating the extension ring. So if a tank has not undergone the maintenance process, you're correct, it has not. So if I think 14, so we currently have 4 tanks undergoing the maintenance process now. So yes, that will be 14.
Okay. So those 14 tanks remain at risk. I mean, if the polysulfide is intended to reduce the risk, these 14 tanks that are still in operation, the risk remains.
Yes.
Okay. Another protective measure you mentioned is decommissioning smaller nozzles, and Mr. Brown talked to you a little bit about that. And those smaller nozzles are at the bottom of the tank, right?
Yes.
And decommissioning the nozzles reduces risks.
Yes.
And there are 14 tanks still have the smaller nozzles attached to them, correct?
That's correct.
So the risk remains for those 14 tanks.
So yes, we cannot take them out of service until we complete their maintenance cycle.
Okay.
So of course, we continue to work the mitigation for that risk, and those nozzles, they're actually an extension of the tank. So what we do now is when we do tank tightness testing, semi-annual tank tightness testing, that's a portion of the tank that undergoes that tank tightness testing.
So I don't know if you know this, but this permit that you're applying for is valid for only up to 5 years. Do you know that?
Yes. Mm-hmm. Yes.
So maybe maybe your successor, maybe you'll be there in 5 years. Maybe I'll be here 5 years. Let's say you succeed and get this permit granted from the Department of Health. You'll come back in 5 years, and let's say I come back and talk to you in 2026, January 2026. I'm going to want to know how many of these nozzles you've replaced by the time this permit is over. And I want to hear a commitment from you. How many nozzles do you think are going to be replaced by, let's say, 5 years from now, in 2026?
I'm doing math, so I do not have my CIR schedules in front of me. Certainly, the 4 tanks that are currently undergoing the clean, inspect, repair, and we will probably late mid 2021 we'll induct another tank, 5, at least 6.
So the vast majority of the tanks will still have these small nozzles that pose a risk.
Yes.
Okay. A third protective measure that you've talked about is the tank inspection. And sometimes you guys refer to it as a TIRM, and sometimes you refer to it as a CIR. Is that right?
That's correct.
And these inspections are conducted pursuant to API standard 653, right?
Modified. Yes.
Modified. And that standard, as modified, provides the requirements for the frequency of inspection of these well, as unmodified is for above ground storage, fuel storage, correct?
Yes.
But you folks have modified it because it's underground, right?
That's correct.
And the Navy determined that inspection should take place every 10 years, unless the corrosion rate is such that it can be inspected later, i.e. 20 years, as recommended by the API STD 653 inspector, right?
Yes.
Okay. Now, Tank 3 was last inspected in 1983. Is that right?
That sounds right.
That's nearly 40 years ago.
That's correct.
Tank 3 is overdue for an inspection.
Yes.
And it's continuing to operate.
So tank 3 has not undergone its initial API 653 yet. So the initial API 653, that is what starts the periodicity clock for the follow-on inspections. Yes.
Tank 4 was last inspected in 1983. Is that right?
That sounds right.
Nearly 40 years ago. Right?
Yes.
Tank 4 is overdue for an inspection, isn't it?
Overdue by API 653 standards?
If we want to be protective of the environment, is it overdue for an inspection?
So the inspection cycle is determined by the API 653 engineer based upon the condition that he closed the tank out in. So if we have not inspected the tank, established a corrosion rate, I can't honestly say that it is overdue for an inspection. Do I want to go in and inside and take a look at that tank and get it inspected? You absolutely bet I do.
You know, I'm going to share my screen here so you can look at this document. Close this other one out. So this is that TIRM report. Does it look familiar? TIRM report?
Yes.
Okay. And if you go to page 19-6 of this report, it reads, the next inspection shall be in 10 years unless the corrosion rate is such that it can be inspected later, i.e. 20 years. So has an API STD 653 inspector determined a corrosion rate for tank 4?
No.
Okay. So tank 4 is overdue for an inspection, isn't it?
The next inspection should be in 10 years unless the corrosion rate is such that it can be inspected, i.e. 20 years as recommended by the API 653 inspector. As I read that statement, the API 653 inspector determines when the next inspection is due.
You're telling me under the Navy standards, the inspector can decide that a tank does not need to be inspected for 40 years?
No, that's not what I'm telling you. I'm telling you how I read this document. That's not what I'm telling you, sir. No.
Okay. The Navy requires that these tanks be inspected actually every 10 years unless an inspector says, you know what, this can go to 20 years because of the corrosion rate. But you don't have an inspector who's told you that tank 4 can wait 20 years. No.
That won't happen until we take the tank down, clean it, and inspect it.
So that tank 4 is overdue for an inspection, isn't it?
We don't have any inspection history on it, so I guess you can say that it's overdue for an inspection, simply because we don't have inspection history on it.
And it's continuing to operate, isn't it?
That's correct.
Tank 7 was last inspected in 1998. Is that right?
That sounds about right.
More than 22 years ago. Is that right?
Yes.
Tank 7 is overdue for an inspection, isn't it?
Yes.
Tank 8 was last inspected in 1998. Is that right?
That sounds about right.
More than 22 years ago, right?
That's the math, yes.
Tank 8 is overdue for an inspection. Is that right?
Is it a question?
Mm-hmm.
Yes.
Tank 9 was last inspected in 1995, right?
Sounds about right. That's what the records show.
More than 25 years ago, right?
Sounds about right. Yes.
Tank 9 is overdue for an inspection, isn't it?
Yes.
Tank 10 was last inspected in 1998. Is that right?
Not sure, but if that's what the record states.
More than 22 years ago. Does that sound right?
The same as the other tanks, yes.
Tank 10 is overdue for an inspection, isn't it? Isn't it?
I'm sorry?
Tank 10? Well, okay. Tank 10 was last inspected in 1998, right?
Okay, yes.
What, more than 22 years ago. And tank 10 is overdue for an inspection, isn't it?
Yes, by that standard, yes, it is.
Tank 11 was last inspected in 1981?
Maybe 83, 81 or 83.
Okay. Nearly 4 decades ago. Is that
Yes.
right?
Mhm.
Tank 11 is overdue for an inspection.
Yes.
Tank 12 was last inspected in 1995. Does that sound right?
That sounds right, yes.
More than 25 years ago.
If that's the math, yes.
Tank 12 is overdue for an inspection. Is that right?
Yes.
So you identified 3 protective measures that decrease the risk, that are necessary for protecting our environment, recoating certain areas with the polysulfide, removing the small nozzles, and inspecting all the tanks. And within the next 5 years, none of those 3 things is going to be accomplished for even close to a majority of the tanks. Isn't that right?
So no, we cannot shut down the entire facility. We have to phase our maintenance in. So I'll go. I can go a little bit on this one here, and this is probably a question. All right, better suited for our ex-wick maintenance specialist. So no, we cannot execute all of those measures at this time. All right. However, the other portion of my testimony, all right, that discusses our system of systems on how we're ensuring that we're operating the tanks in the most environmentally protective manners possible, all right, is our continued tank tightness testing that we're doing twice a year, which exceeds the requirement of the state, the requirement of the HAR. Our soil vapor monitoring that we're doing, our groundwater monitoring, all of these things that detect if we're releasing something into the environment. So in addition to, there are other things that are in addition to the maintenance procedures that you spelled out that we just simply cannot do. So I'd like to draw your attention to the other things that we're doing to ensure that we're operating the tanks in the most environmentally protective manner possible. All right, our strict operating protocols. All right, the way we respond to alarms, the way we track and monitor our fuel inventory. Most importantly, our tank tightness testing. All right, that tells us that the tank is tight, that it meets current EPA requirements, and I feel good about that.
And have you looked at the ABS report that estimates that over 5,000 gallons of fuel are expected to leak every single year through chronic conditions?
I'm not sure if it said that. However, if there is a release below the minimum detectable threshold of 0.5 gallons per hour at 0.499 gallons per hour, I think if the tank was releasing, it would release up to 4,300 gallons, I believe the math comes out to.
Okay, thank you. No further questions.
Okay.
All right. Mr. Page, any questions?
Yeah, just a couple questions. Deputy Director Floyd, going back to the October 2020 inspection. Is it your understanding that there's been no final report issued regarding that inspection?
That's correct.
Okay, so would it be fair to say that any major findings or issues or concerns have not been conveyed at this point?
So no, nothing has been conveyed at this point. Upon our debrief after the 2-week inspection, very thorough inspection, the lead inspector had no significant findings. So if there was nothing significant at the conclusion of the inspection in October, I could reasonably inspect that there's would not be anything significant that would be added on later.
Okay, and you made a statement, the inspectors reported the infrastructure was clean and pristine with no fuel leaks. Is that a statement you're attributing to an individual, or is that an impression?
To an individual, yes.
And do you have any other information concerning specific findings or concerns that were conveyed during that time period?
There was some concern, questions about our third-party certification for our tank tightness testing, but we got that one resolved. But nothing that specific that I can call out now, no.
Okay, and then going back to the evaluations that were conducted in 2016 with the 5 PLL SMEs. You mentioned Eastern Research Group, Aspen Controls, PEMY Consulting, Atlas Geotechnical, and Powers Engineering and Inspection. And then you indicated that these companies were selected by DOH to be part of the evaluation inspection team. What do you base that on?
I'm sorry, say that again, please.
You had indicated that the 5 POLs were actually selected by the Department of Health to be part of the evaluation inspection team. I'm wondering if that's a correct statement.
That's incorrect. All right, they were contracted by EPA Region 9.
Okay. I think that's all the questions I have for now.
Okay, any redirect?
We would request just a break, a little break before redirect.
Okay, I've lost track, but have we gone sufficiently? You want a short break or you want to take a recess of 15 minutes?
A short break, just a short break.
10 minutes?
Maybe 10 minutes. Yeah.
All right, 10 minutes, we'll recess.
Great, thank you.
Okay. Off the record. I think we are reassembled. Does anyone want to wait for anyone else to appear? Okay, if not, let's go back on the record. Ms. Minot, were you conducting the exam
Yes.
here?
Yes.
Does the Navy have
Yes.
redirect?
Yes.
Okay.
Just a couple of questions, Mr. Floyd. I wanted to first kind of go back to you mentioned that the inspection for the last two tanks that's part of the new term process, CIR process, is set to begin, currently scheduled for 2032, correct?
Yes.
And when these last two tanks go into service, at what point in time is the fuel drained from them?
The last two tanks?
Yes.
That will be 2032.
Okay, thanks. And are you familiar with the military unified facility criteria?
Yes, there are various
UFCs?
UFCs, not all of them, more especially 463 maintenance, 461 to some extent. That's the design criteria.
And we heard before from Chemo that there is a 20-year inspection periodicity. Is that based on the UFC code?
No, I'm not sure. I just know that's the based upon the inspector's last record, inspector of record, their recommendation. So I'm not.
And are you aware of any? Oh, sorry.
I'm not. I can't quote the UFC to you. Sorry.
Okay. Are you aware of any Hawaii requirement or hard requirement for that 10 or 20-year inspection periodicity?
No.
Are you aware of any? Okay. No further questions here.
Okay. For BWS.
I just have one question for Mr. Floyd. Mr. Floyd, we just learned this morning that in the event of a catastrophic release that isn't directly to the environment and makes it into the access tunnel, that the access tunnel could potentially hold that fuel. As the person responsible for maintenance, are you aware of any tightness test of the tunnel that's been performed that can conclude that it will hold that fuel?
No, I'm not. I'm aware of the oil pressure door that was newly installed and that was designed to hold the contents of one full Red Hill tank.
But there's no access tunnel tightness test, is there?
No, not that I'm aware of.
That's all I have.
Okay. Mr. Page, do you have any follow-up?
Nothing further.
Okay. Mr. Frankel, I'm sorry, I think I skipped over you. You have any follow-up?
No, thank you.
Okay. Let me ask the questions that I have. Mr. Floyd, it appears that you began your work at Pearl Harbor sometime after the 2014 spill release event. Is that right?
Yes, sir. I began in February 6, 2015.
Okay. I suppose things were very critical and challenging at the time that you assumed the position. What was your role in responding to the event that had been reported about the release in 2014?
My role, arriving post-event, I arrived in the final stages of developing the AOC, the Administrative Order on Consent. I had operator input into all of those sections, specifically sections 2, 3, 4, and 8. my primary role as an operator was to fix the wrongs of 2014, specifically in how we responded to alarms.
So when you began, had the investigation as to what went wrong been completed, or was that in process?
The investigation had been completed. Yes, sir.
So when you said your role was to fix the wrongs, tell me more about that. What did you work on?
I worked on the term, how we inspect and repair tanks. I had operator input there. I had operator input, significant input on section 4 of the AOC, the current release detection monitoring systems, specifically how we responded to alarms. Also with our tank return to service procedures. There's an overlap between sections 2 and sections 4. I had input into how we return our tanks to service after repair. It was a big deal because this is when a tank is most vulnerable, and that is what happened with Tank 5.
Did you have any role in the investigation of the release in terms of what happened, where did it go, and what damage resulted?
No, sir, I did not.
Are you aware of what was done to try to answer those kinds of questions? What happened? Where did the fuel go?
I'm aware of those questions. To the best of my knowledge, that is still ongoing with sections 6 and 7 of the AOC, where we're looking at remediation of past releases, as well as trying to develop a fate and transport model that we can, some type of modeling to show where it could possibly go or where it's at now. So I was on the periphery of that. I was not directly involved with that. That was mainly our environmental staff and their contractors.
Okay. Your testimony identifies your major roles, and one of them was to develop long-range plans to maintain infrastructure to ensure performance, safety, environmental compliance, etc. Is there such a plan?
Yes, sir. It's ongoing. It's a very dynamic plan. One is our tank inspection and repair and maintenance, how we cycle tanks in and out of service for maintenance. Looking at upgrading our technologies. This year we'll be we have funding set aside, and we're developing a project to put in full-time tank tightness testing or release detection testing. We're getting ready to pilot full-time, real-time soil vapor monitoring. We're in the initial phases, or stage 1, I believe, of piloting one tank for new double wall technology. That's just a few of them. So there's no one comprehensive master plan to incorporate all of these changes. I guess it can best be defined under section 2, the TUA, the tank upgrade alternatives. And I've been involved with that. And hopefully that's going to be the document that wraps it all up, will be our overarching and our guiding document for the next 20, 25 years or so as we work on getting all of their tanks upgraded.
What is the progress of the double wall technology? Pilot.
Last year, we contracted, NAFAC contracted with a French company, GTT Technologies, and they are developing a pilot. I think for FY21, we're going to do a design concept beginning late FY22. We will begin the pilot or the construction of the initial pilot in one of our tanks. So that's to prove up the concept.
What is the double wall technology that is being considered?
So I'm not an expert on this. I think you're going to receive testimony on this later, perhaps from Mr. Frank Kern from Exwick, who's the lead on this one. But we're looking to adopt technology from the liquid gas industry that this company, I think they got like 70% of the market share. They developed the technology to double line the LNG carriers, and roughly, actually larger on scale than a Red Hill tank. This is reported to be a proven technology, so that we will have an additional hydraulic barrier inside the tank with interstitial monitoring that we could monitor the interstitial area between the new double wall technology and the existing tank liner.
Do you know the material, anything about the material being considered?
I believe, I'm not sure. It may be a honeycomb type stainless steel. I'm not sure.
Okay,
Yeah.
Thank you. One question I have is generally about the connection or the interrelationship between the AOC and the HAR regulation requirements. Are they the same? Are they different? Are they parallel and similar? What's the relationship?
Each one takes up a significant portion of my working volume, and I tend to keep them separate. I view the AOC simply what it is. It's a bilateral agreement between Navy, DLA, and the regulators that provides a strategy for improving and upgrading the operations and maintenance of Red Hill. Whereas the HAR, Hawaii Administrative Rules, is law. All right, this is a law that defines how we should operate the facility. So as a pretty clear distinction for me as an operator, the HAR provides a framework, that's the law, and these are the articles that we have to comply with.
And presumably the effort of the AOC is to meet those requirements.
So in a way, it certainly will, but I see the AOC as being more in terms of our strategic planning, all right, on how we operate the facility and how we make it better and more protective of the environments in terms of what upgrades we can implement, how we conduct our maintenance, how we conduct our leak detection. So there is, in some cases, some overlap. But again, for me, I do not have a problem viewing those as separate and distinct.
Thank you. I have a sense that we have a very dynamic situation and things are changing. And so the circumstances at one time will have changed. So I have some questions in that regard. Your testimony references the findings of the 2017 final evaluation report.
Yes, sir.
So I have a general question of between the time of that 2017 FER and today, what, if anything, significantly has changed?
In what context, or in context of the law, or how we operate the facility?
Actually, both would be fine. You can take them one at a time.
The 2017 report, the inspection took place in 2016. That was a baseline assessment that was to, one, help the regulators determine how to regulate a facility such as ours, and two, a baseline assessment on how well that we align with the 40 CFR rule, 40 CFR 0.112. And at that time, it was stated that we were meeting and exceeding all industry standards. From that, as the HAR developed, there were no significant hurdles that we had to meet in order to come in compliance with the HAR because of what we were already doing in 2015, 16, and 17. So it was a fairly easy pivot, although we were not being regulated by the state. There were no significant hurdles that we had to overcome in order to get to where we needed to be.
Okay, so between the 2017 timeframe and 2021, no other significant changes?
No, sir. So our biggest challenge was working with the state, making sure that they understood how our facility operates, because there were some portions of the law that were not aligned to a large facility such as ours. So the law, as written, you simply cannot regulate a Costco station and a Tesoro station the same way that you'd regulate Red Hill. So that's been our biggest challenge.
Okay. Your testimony also refers to a 2020 inspection that was done by the Department of Health. Are there documents that set forth the findings of that inspection?
No, sir. The final report is pending.
And the final report is to be issued by whom?
The Department of Health.
Okay. In your testimony given earlier, you referred to, or there was discussion about this polysulfide coating. And as I understand your testimony, you're saying that the early work with this is to coat the lower dome and the is it extension ring? Extension ring,
yes, sir. So the extension ring is so tanks 1 through 4 were slightly smaller. So tanks 5 through 20, they were made larger by adding that extension ring onto it. So I think you walked inside of a tank. When you walk inside, just directly above the 8-foot portal that you enter the tank, that's the area that's called the extension ring. This is where the barrel transition into the upper dome of the tank.
And there were some steel elements that seem to protrude. Would that be the line of the extension ring?
Yes, sir. So those you're probably referring to as the backing bars of the tank. That portion of the tank was constructed and welded from the outside. We use backing bars there. So the extra metal that you see inside the tank would be those backing bars. All right. So that was a known point of weakness in the tank and during construction. So we're going to put that coating of Novalax epoxy on that as an extra protective measure. In addition to that, we've lowered our fill height also for tank 5 and all subsequent tanks. That fill height will be underneath the extension ring.
Your reference to the term lower dome, I am understanding that to be the bottom of the tank.
Yes, sir.
Is that right?
Yes, sir.
So why would the coating be of the lower dome only and up to that extension ring? Why only that portion?
This is a question I could probably be better answered by one of the tank repair specialists. But the lower dome is where any water in the tank will collect. Water is always inherent in fuel. And as the fuel sits into the tanks, any entrained water will leach out of the fuel and collect in the bottom of the tank. So the tank bottom, to add just an extra protective measure, we put that coating on there, all right, as another barrier against corrosion. And the extension ring, all right, just in the manner that it was constructed and the number of indications that we've seen in the extension ring, we found it would be prudent to put that extra barrier there also.
So is this polysulfide material only applied to the lower dome, and then there's a gap, and it's applied in the area of the extension ring?
Yes, sir, currently. All right. And to some of the repairs that are made in the areas of the patch plates.
Okay. So it's kind of a spot application only.
Yes, sir.
Yeah. All right.
Mm-hmm.
Thank you very much, Mr. Floyd. Appreciate your information. Councils, any follow-up questions?
I have a few follow-up questions, Hearing Officer Chang.
Okay, go ahead, Mr. Brown.
Mr. Floyd, you were just speaking about the polysulfide coating on the interior of the tanks. And my understanding was that this is applied, as Hearings Officer Chang had just mentioned, at the bottom, sometimes at the top, and then it looks like on the patch plates. Is there any coating that is applied to the backside of the steel liner?
Not that I'm aware of, but again, that may be a question better asked to the tank repair specialist.
So are you saying that you can access the backside of the steel liner in these tanks?
No, you cannot.
So you couldn't put a coating on it then?
So ask your question again, please.
So is there a coating on the backside of the steel liner?
Not to my knowledge, no.
And the coating is what you're saying is protective of corrosion, right? From the inside?
Yes.
And the corrosion that we looked at on each of the 10 coupons from tank 14 was on the backside of the steel liner.
Yes.
So there is no coating, and there's no way to put a coating on the backside of the steel liner, not to your knowledge.
No, it's not. However, once we install a new patch plate, I'm not sure how that's treated before it goes in.
Okay. And the other question I had, just a couple of quick follow-ups. You had mentioned the difference between the regulations before and after the 2016 inspection. Were the or sorry, is the HAR more stringent than the federal regulations for USTs? That means, are there more requirements?
I wouldn't know.
You wouldn't know.
No.
Okay, I have nothing further.
Okay. Oh, we have any other questions, Mr. Frankel, Mr. Page?
None.
And the Navy has no more questions.
We do not. Thank you.
All right. Mr. Floyd, thank you very much.
Sure.
Okay, let's go off the record and decide where we go here from here. We're ahead of schedule, folks. Good work. What's your pleasure? You wanna call it for the day, or you wanna do some work for tomorrow?
Yes, sir. I think we need to call it for the day. Our witnesses that we lined up are all in different time zones. So we're going to start at an East Coast time zone and work our way west. So if we could reconvene in the morning at 8 o'clock, we'll start our next witness with Mr. Caputi.
All right. Any other admin issues, scheduling issues from anyone? Everybody okay?
We may have some in the morning, but nothing that we can think of.
All right. Very good. It went pretty well today. Thank you all for mastering the process here.
All right.
So we shall see you all tomorrow at 8. I am planning to open up the site at 7:30. So in case you want to, get in early and stuff, if you need more time than that, then I can come in earlier. So I will see you sometime 7:30 to 8 tomorrow.
All right. Have a good night.
Thank you.
All right, everybody. Take care. Bye-bye.
Thanks.